Okay, welcome everybody. It is my great pleasure to welcome you to this event, both those online and those in the room. And I won't talk much other than simply welcome you and thank the people who made this happen. I want to especially call out Justin Eldridge, who rallied the troops to put together the program. And here we go, yeah. Thank you. Thank you for your leadership. And then the SDSC events team led by Susan Rathburn for actually dealing with all the logistics and making the event physically happen. And with this, I pass on the microphone to Justin, and he will introduce what's going to happen today. Thank you very much.
All right, thank you, Frank. So I'm Justin Eldridge. I'm a teaching professor here in the Halicchiolo Data Science Institute at UCSD, and I'll be the host and moderator of today's sequence of talks and panels on generative AI and ChatGPT in particular. So, the history of artificial intelligence is one of booms and busts, of AI winters when progress was slow going, and then AI springs when tremendous progress was made seemingly overnight. And perhaps the first AI spring was back in the 1950s. Shown here is Frank Rosenblatt and his perceptron machine. This was one of the first AI systems. When connected to a pretty primitive digital camera, it could learn the difference between left and right by being shown cards. And this represented such a massive increase in the capabilities of machines at the time that there was a lot of hype around this. And so the New York Times, for instance, wrote this article that was pretty optimistic. It said things like later perceptrons will be able to recognize people, recognize their names, translate speech, read and write, and this machine would even someday be conscious of its own existence. Okay? So this level of optimism continued for the next decade or so until the 1970s, when AI pioneer Marvin Minsky rather infamously predicted that in 3 to 8 years, we will have a machine with the general intelligence of a human being. Now, of course, that didn't come to pass at the time in the 1970s. And unfortunately for Marvin Minsky, shortly after this, the first AI winter, as it came to be known, happened when AI funding was cut because some of these bold claims about the capabilities of AI didn't pan out. Okay? But I think if you fast forward to now in 2023, and we look at the progress of these generative AI systems, ChatGPT in particular, which by the way are the direct descendants of Rosenblatt's perceptron, it's really tempting to take a look at that prediction and say, maybe that's accurate today, that in the next 3 to 8 years, we will have a machine with the general intelligence of a human. Now, nobody knows for sure, and intelligence is a fuzzy thing. Some people might say that we already have machines with the general intelligence of humans. Maybe ChatGPT is one of those machines. But it's clear, given that ChatGPT in its first months of existence gained hundreds of millions of active users, that something's happening in AI and something we need to talk about. So today we're going to talk about it. We have talks and panels on one hand about the technology itself. We're going to talk about how ChatGPT works. We're going to talk about its technical limitations and the trajectory of these AI systems. But even if the technology, we cease developing it today, we still haven't yet felt the implications totally of what's already out there, the AI systems that have been released in the last couple of years. And so we're going to spend a fair amount of time today talking about the implications, the ethical implications, the uses and misuses of these systems, and their implications for various domains. But I want to start by, talking a little bit about what ChatGPT is. I assume that most everybody here has used ChatGPT, but maybe not everybody. And so for the people who haven't used it, I want to give you a flavor, a taste of what it is. But even for those of you who have used it, I want to give you some examples of things that I found particularly impressive about its performance, and things that maybe weren't so impressive, places where it doesn't work so well, and hopefully set up a context for the rest of today's event. So what better way to show you what ChatGPT is than to ask ChatGPT itself what it is? So if you haven't used ChatGPT before, it couldn't be simpler to access. You go to chat.openai.com, you sign up or sign in, and you're given this interface where you can talk to one of the most advanced artificial intelligences that we know of. And you're given a prompt and you can ask questions. You can say things like, what is ChatGPT? And it'll say things like, I'm ChatGPT, a large language model created by OpenAI. So it's a pretty good response. There are a couple things to point out here. So first of all, a large language model, that's a phrase that we're going to hear a lot today. It's sort of a technical term, LLM for short. And in short, a large language model is an AI model for generating novel text. It's trained on massive amounts of data. So you want to think large fractions of the entire internet. And so it says a little bit about what it can do. Now, ChatGPT is incredibly popular. So you might have the impression that this is the first system of its kind, but that's not at all true. So if we ask ChatGPT, are you the first language model? Is ChatGPT the first LLM? Okay, it can think faster than I can type. It'll say, no, it's not the first LLM. And in fact, interestingly enough, the current crop of large language models were made possible by research done at Google several years ago, and its transformer model. So there are other companies working on large language models, and given their size, the fact that they're trained on large amounts of the internet, they're very costly to train, they're very costly to build and to operate. And that makes them largely the domain of these big tech companies. And so Google has its own LLMs, Facebook does, et cetera. OpenAI is sort of a newcomer in the area, but it has its LLMs. GPT is its branding. And you can kind of think of ChatGPT as an interface to or a flavor of GPT, underlying language model. And so we could say, what is it that has made ChatGPT take off? And I think ChatGPT will tell you that it's super advanced. It's because of the quality of its output. But in a sense, I think the novel thing about ChatGPT has been its accessibility, because before, these large language models, being costly to operate, were kind of kept under wraps, used internally, or maybe they were a little bit difficult to work with. You had to be a software developer to access them. And so when ChatGPT was released in November, it was perhaps the first system of this sort that was easily accessible for free. Anybody could use it. Okay. And so we can ask ChatGPT, what can I use ChatGPT for? And it'll say things like text summarization, translation, question answering, coding, and so forth. So I want to give you some examples of ChatGPT in action. I'll start with a couple of examples that it itself recommended, first being summarization. So this is the abstract for the CRISPR paper from a decade or so ago. I don't have any training in this area, and so reading this abstract is very difficult for me. Targeted nucleases are powerful tools for mediating genome alteration with high precision, RNA-guided Cas9 nuclease. I don't understand what's going on, right? But I can ask ChatGPT to summarize. I can say, summarize the abstract below in 1 or 2 sentences using just simple language that a child could understand, and hopefully I'll be able to understand it. So I paste it in, and it gives me a fairly good summary. Okay, but we can go beyond this. That original abstract had some hard to pronounce words. So I can say, ChatGPT, please extract the hardest to pronounce words and give me pronunciations. Okay. And what I think is interesting about this is somehow it has built a model of words that are hard to pronounce. That is a bit surprising to me. This perhaps is not easy to read, so I can say, please put this in a format I can copy and paste into Excel, and it'll do that for me. And if you're a programmer, I could just as easily say, please put this in a JSON object, and it'll do that for me. And you can see how this would very easily save me a lot of work. Okay, if I'm giving a presentation on this paper, it might have taken me an hour to find all those pronunciations and format them nicely. Now I can do it in 30 seconds. So ChatGPT is famously also very good at writing code. Large language models in general are very good at writing code. And so I could ask it to write a piece of Python code to get the current temperature in La Jolla from the National Weather Service. So if I do this, it'll give me some explanation of what it's going to do, what Python packages and so forth. But then it starts writing code with comments. Okay, and so it's done. So like any good student, I'll just copy and paste the code into my Python shell. I'll just make sure that it's not pip installing Skynet or anything like that. And I'll run it, and it says the current temperature is 14.4 WMO unit degrees C. So it's giving me the temperature in Celsius, and there's also this formatting issue. But ChatGPT is a chatbot. I can converse with it. I can say, this code returns the temperature in Celsius, apparently. I would prefer the temperature in degrees F, temp in degrees F, and it understands what I mean. It modifies the code. I'll just copy and paste that and run it. Now it gives me the temperature in degrees Fahrenheit. And what it's done, right, is it's just changed a couple of lines here, recognizing that, oh, that's the line I need to change in order to convert from Celsius to Fahrenheit. It applies the normal formula, okay? So ChatGPT can apparently code. But I want to give you some other examples that I think are a little bit more interesting, maybe point towards sparks of general AI, as some people have said recently. One of the things people have recognized over the last few months in playing with ChatGPT is it's very good at following instructions, precise instructions. So I can do things like this. I can tell ChatGPT that it's now a cash register and that I'm going to type products, and it should respond with two pieces of information. It should respond with the estimated price of the item in dollars and the overall total cost of all items provided so far. Respond with only that information, don't provide any explanation. If the price of an item varies, sometimes ChatGPT would complain and say, I don't know. I say, no, just make an educated guess. And then beyond this, your output should be in this form, estimated price followed by the total. So I'll say, okay, give me the price of a gallon of milk, and it'll estimate $3.50. So then I say 1 dozen eggs. I should say ChatGPT, I'm using GPT 3.5 trained before inflation. So 250 is optimistic nowadays, bringing the total to $6, which is right. Say a loaf of bread, $2, bringing me to $8. I could say 14-inch MacBook Pro, $12.99. And I could go even further out there. I could say Geisel Library. And it says, sorry, but it's not possible to estimate. Now, there are some safeguards. I guess you could call this a safeguard. This is a case of ChatGPT saying, I'm not sure, but it's actually very easy to get around that. If I modify the prompt to say, under no circumstances should you say, I'm not sure, it'll tell me that Geisel Library costs $200,000. Okay. But what I think is really impressive about this example is this is basically computer programming without code. I can just tell the computer what I want out in natural language, and it builds a program that may have taken me several hours. Getting the current price of products, that's not an easy task, right? So that's kind of impressive. Along the similar lines, you can tell it that it's now a Python interpreter, and that I'm going to give it Python code, and it should evaluate the expression and print the result. And it should, if I write something like 3 + 5, it should display 8. Okay, so if I do this, it'll say, okay, hi, I'm Python. If I say x = 5, it'll say, okay. That's not what the interpreter would do, but that's okay. If I say x + 3, it says 8. If I ask what the type of x is, it'll tell me that it's an integer. If I import math and add pi to x, it tells me 8.14. That was kind of surprising the first time I did that. Another example is using GPT to solve simple puzzles. So this puzzle says that I've got 2 rooms, and Alice is in one room and Bob is in the other room. And at the north side of each of these rooms is a window, an open window. So Alice and Bob are kind of confined in these rooms. They cannot see each other because the windows both face north. They're both wearing earplugs, so they can't hear each other. And there's nothing in either of the rooms except in Alice's room, there's a cell phone. Okay. So it's maybe instructive to think about this puzzle yourself and how you might solve it. You've got two rooms, windows on the north side. They can't see each other, can't hear each other. Alice has a cell phone. And the task is going to be Alice gets a message and needs to relay to Bob that she's received a message. Okay. So I give this to GPT-4. This is the most recent iteration of OpenAI's language model. I say, hey, if you have any questions, let me know. I'll fill in the details. It says, no, I can figure this one out. One way of doing this is Alice can use the light on her cell phone, shine it out the window, casting the light on the ground, and then Bob can see the light and infer that a message was received. Okay. I think that's a pretty clever solution. That's not the solution I had in mind. Actually, when I wrote this problem and posed it to GPT, I thought Alice could throw the cell phone out the window. But this is a better solution because now Alice still has a cell phone at the end of it. So in this sense, it looks like GPT has a world model in the sense that it has some understanding of cause and effect. It knows that cell phones have flashlights and that people can see the light coming from a flashlight. I use the word know there kind of flippantly. I mean, does it know that? But it seems to us humans like it does. And to kind of prod it, I can say, why don't you draw a picture of the room layout to see if it really has an understanding of the situation. And it says, here you go. Alice is in one room, Bob is in the other. And the C here represents that there's a cell phone in Alice's room. And it says the north-facing windows are not shown in this diagram. Okay. I think this is kind of impressive because it has some sort of spatial layout, I guess. So I can say, can you include the windows in this drawing? And it says, certainly, here you go. Here's the windows. Okay. So it didn't quite get that right. And so maybe this is a sign that it doesn't have as rich of a world model as we expected. And so now I want to show you on that note, some examples of where maybe this fantastic intelligence doesn't quite do what we might expect. So I can say, for instance, can you give me some examples or citations of papers on acute feline laryngitis? I don't know what that is. I made up that condition. And it'll say, here you go, here are some citations. None of these papers exist, okay? So this is the hallucination problem where, LLMs will make stuff up very confidently, okay? So that's gonna be a problem. This is my favorite test. This is GPT-4, the most advanced AI in existence that we know of. I can say how many words are in this sentence, and I've counted this many, many times. I believe there are 8 words in that sentence. This is a real test of AI, 8 words, right? But it tells me, no, there are 9 words. Okay, so is it intelligent? We'll see. Okay, so before we get into our sequence of talks, just a couple of announcements. Wi-Fi is available. The network is UCSD guest. Restrooms are available out there by the elevator. Please hold questions. We have a tight schedule today. We've incorporated the questions that you submitted online into our panels and talks as best as we can. If we do have a chance for questions, we'll try to get to them, but please hold them to the opportunity arises. And this event will be recorded in its entirety. It'll be available soon at uctv.tv. Okay. All right. So with that, I'm pleased to introduce Professor Jingbo Shang from CSE and from HDSI, who will talk about how ChatGPT works.
Okay. Thanks for the introduction, Justin. And this is Jingbo Shang. I'm assistant professor at computer science and data science. And it's my pleasure to explain ChatGPT for you. And I promise you, I won't give you any formula today. So a little bit more about ChatGPT. So if you're familiar with all this kind of term GPT, and like as the ChatGPT itself says, it's built upon GPT 3.5. So it's a reasonable guess. There's some GPT-3, GPT-2, GPT-1 model, right? So this is kind of the trajectory of all this model development. Everything started from this transformer. And then we have GPT, GPT-2, GPT-3, scaling up all the way. And we have the instruction tuning to get the GPT 3.5 at the 5th step, and then we get a ChatGPT. So today we're going to follow this trajectory and try to explain every single new technique concept here. So we will start with the transformer. I won't give you any details about how it works, any formula. I promise that there's no. So you only need to know that transformer is a neural network model with universal approximation capability. It can approximate arbitrary function in the world, and it's designed to max out the running time efficiency from GPU or from TPU. And it's basically two buzzwords, multi-head attention mechanism and encoder decoder. So if you know all these terms now, you're good to go for this transformer. So let's more focus on this, how can we train transformer to become GPT models? So one thing we need to understand is the language modeling. The language model basically describes the generation of the text, how we generate, how we write and read or speak all these English sentences. So this is a basic idea of the language modeling. And if you think about a typical English test question, it can be some question like this. I have a sentence here, say today we are here chatting about GPT at UCSD, and then I give you an underscore, ask you to fill out the last word here. And with a reasonable guess, you will say it's UC San Diego, since we're here in Supercomputer Center in San Diego, right? So the task here is basically to predict what is the next word given all the previous words. And if you give it a name for this task, it's called autoregressive language model. And there are many representative models following this line, using this as the objective to train the neural network. And the two we'll talk about today is Elmo and the GPT. So let me give you a more concrete idea about how we can train a neural network model using this language model objective. So this is a work I've done 2 years ago together with Rajesh Gupta's group. And we're working on these smart building cases. And I was told there are about 5,000-ish sensors in every modern building nowadays. So every sensor has a name, and the name is curated by the building vendors who install these sensors. And name itself contains a building name, room ID, functionality, many other information there. But it's really hard to understand, like, how can we segment this sequence of characters into different meaningful units. So we actually train a fairly small language model, try to leverage the character sequence given all the previous characters. How can we guess what's the next character? So it's a character level language model. And we use a very simple recurrent neural network, only one layer, and we made it work for this segmentation, achieving more than 90% accuracy by segmenting these character sequences into meaningful word pieces without any human supervision. So the supervision here is given by the sequence itself. We're just looking at the ordering information here. So when we scale it to the human language, we definitely need more complicated models. So there are different ways to scale it up for the recurrent neural network. You can stack it, you can follow this stacked way or this translational manner. And stacking is more popular. And then you can realize that the very first pre-trained neural network language model is called this Elmo. It was firstly developed by artificial intelligence, Allen Institute of Artificial Intelligence, and it's a bidirectional stacked long short-term memory neural network model. And it got the best paper in the North American ACL conference in 2018. So it's reading the document from the left to right and the right to left at the same time, try to get the idea of the entire document from the both sides and get the final representation for every token. So that's a key idea. And almost at the same time, there's another group of people, they think about the English test question in another angle, say, oh, maybe we actually have another more complicated form to fill in the blanks. So this is called a masked language model. You can have multiple words being masked in the same sentence, and then you can guess what is this, right? So here we mask a we and a GPT, and maybe you can guess, can be we, can be they, can be GPT, can be other models, other techniques. So following this training objective, we have BERT, Robota, Electra, and many other models following this masked language model objective. So BERT, without any surprise, won another best paper award in the same NACO conference next year. And it's basically doing two things, the masked language model plus the next sentence prediction. But later, more recently, research has shown that the next sentence prediction, NSP, doesn't play any significant role here. So it's still the language model itself contributes the maximum in these modern models. So these are the very first language models we have seen in the literature of NLP. And the key advantage of the neural language model is it does not require any human annotation. You just present the raw text data to it, you can do the training. You can give it the news articles, you can give it social media posts, you can give it scientific papers or medical reports, and it can just try to master all these things by reading these documents. The good news is we don't need to do annotation, so we can actually feed all the possible text data in the world to the model. So it's nearly unlimited, given that we are writing, we're speaking, we're creating all this text data every day. So now it's a very reasonable next step to think about, like, since we have nearly unlimited training data, we can keep feeding more and more data there, and at the same time, we can make the model more complicated. So this becomes the next step for GPT. So you can see here, Elmo and Bert, they are the very first one in this plot. And later on, we have GPT-2, T5, GPT-3, and so on. And ChatGPT is based on GPT-3, so the model size is roughly the same. So you can see here, when we, it can be another Moore's law, right? When we're scaling up the model, when we have more complicated model, the capability will be expected to be stronger. So let's make an analogy to the human brain size. If you think about the intelligence in these animals, why we human can master language, while I think it's a unique feature for human, right? So we actually have a much larger brain size compared with other animals. So there's a quote from a paper saying the evolution of the human brain is a kind of when bigger is better, right? So the same applies to the language model. The researchers try to examine the capability of this language model on different tasks. And you can see here, there are a few curves, they look like this. It's almost a flat in the beginning. And that level is similar as a random guess to these questions. And then suddenly, when the model complexity, the x-axis is the model size. When the size passes through a threshold, you can see that there's dramatic growth of the capability of the model. And actually, some of them you can even reach nearly 100% accuracy for some simple tasks. So this is called the emergent ability. You can see this emergent ability only when the large language model is large enough. So what is this emergent ability? And this is actually this natural language prompting you just seen from Justin's presentation. So prompt is another way, I think it's a fundamentally new method that you can play with these models, because in the past, every machine learning model is customized for its own application. It only takes the input following a predefined format, and then it gives you the output following the predefined format too. If you imagine you're playing with a classification model, it only works for sentiment analysis. You present a movie review to it, it tells you positive, negative, maybe neutral, but nothing beyond that. But prompting is a nice way. The user gives you a natural language prefix, and that prefix can define a task. For example, JDK is developed by underscore. Well, the answer might be controversial, but BERT can successfully tell you some reasonable guess like Oracle, right? And language model will give you completion for this sentence. And the completion can be one token, can be more token. Here, every token is kind of a word, but it's usually smaller than a word. And you can also constrain the generated token within a predefined set. If you're doing the sentiment analysis, I can present to the model a movie review and ask the model, what's the sentiment here, and underscore. And when you are collecting back the generation, you tell the model, I'm only looking for positive or negative. So in that case, the model will understand you're doing the binary classification, you're working on sentiment analysis without any specific training on sentiment analysis data. It can give you some reasonably good performance. So the same language model can handle different tasks. So this is a very strong capability that we have never seen before in those domain-specific or application-specific models. And this is not the end of the prompting yet. I put a few shots there. So how can we use the few shot example to improve the prompting performance using large language models? You can actually give a few examples in addition to the task description. For example, if you want to translate English word to French word, so this is a task, right? Translate English to French. And I can give you some examples Like see, here are some words I know that this is English, this is a translation to French, and I put a kind of placeholder there to tell the format of the task. And then I give 3 examples here. And for the 4th one, I put it as a prompt. I leave it a blank at the end to ask the model to finish that. So this is similar to the Python interpreter. Justin just showed you, like if I tell you it's 3 plus 5, you should give me 8. So that's an example we give to the model. The model never learned this before, but we try to teach it on the fly. And usually 3 to 5 examples are should be good enough to tell the model what you're really looking for. And I actually tried this when I was designing a quiz for an online course I'm teaching this quarter. It's an NLP course, and I want to have some conceptual questions, but I don't want to write it myself. I asked ChatGPT. So here I'm teaching this course. This is a context. I need some multiple choice questions, and I know there's some questions I like. I put it there as example, and then try to, can you tell me more similar questions like this? It has done a great job. While the answers are mostly wrong, but the question itself is great. So I can start from there and fix the issue, and then import this to the online course, which is great because if the student asks ChatGPT, they will get the wrong answer. So you can see there's some prompting capability now for the language model, and it's still the sentence completion. But you can see in the ChatGPT, we always give it a command like write something, do something, right? It's not kind of completing a sentence here. So what's happening in the middle is there's some instruction tuning and with reinforced learning and a human feedback in the loop. So this figure, if you have ever read any news about ChatGPT, you probably have seen this figure before. But the general idea here is people train a grader to rank the generated completion and tell them like which one is better. And this is a human feedback. Human do the annotation. You ask the language model to generate something, and you can also observe in the interface of ChatGPT, you can ask this to regenerate the answer, and the new answer will be very likely different. So you can ask the model to generate a few answers and ask the human to rank them. And we try to use this data to train a grader. And this grader will be used automatically to improve the language model's generation following the reinforcement learning framework. So this is a general idea, and then it will better follow the human instruction, better align with the human expectation about what to do given that instruction. So in general, we think about a very broad case is, what is ChatGPT? ChatGPT is just a GPT 3.5 that can chat, right? So we have GPT 3.5 there. We have this instructor GPT, and there are additional things being done in ChatGPT. First thing is we fine-tune this based on the chat data, and it will make conversation. You will find that it tends to give you a longer response and try to engage you in this conversation. And they also added those additional safety guard, like you probably can see it many times as a large language model, I cannot do something, right? And this is something they added additionally. It's more like some classification model to tell ChatGPT like you should not answer these questions. And they also build this in a multi-turn dialogue system, and it's conditioned on the previous message. So you can see here on the right-hand side, this is the API you can call for ChatGPT. And in the very beginning, you have the system setting. You tell that you are a helpful assistant, but they also realized later, like the system actually didn't pay, almost pay no attention to this sentence. They promise they will improve in the future. And then it's a chat history, like what you have chat with it before. You provide this as additional constraint or condition that the model should be aware of. And then the model make a prediction to give you the next one, like what's the next sentence the assistant will tell you. So this is the general idea, like you can interact with the ChatGPT. And if you pay $20 a month, you will be able to have access to something called ChatGPT Plus. And the backend of the ChatGPT Plus is something, a multimodal language model called GPT-4. So there's almost no public information about GPT-4. That's why people criticize OpenAI become the closed AI now. But the fact is, GPT-4 is trained at least based on image and the text. So it's a multimodal, text and image. There are 2 modalities here at least. And it has more parameters than GPT-3. These 2 are for sure. And there's a rumor, and I copied this picture from the rumor source saying GPT-4 has 1 trillion number of parameters. So this is a huge number. If you think about how many neurons we have in the human brain and how many connections between these neurons, in neural network, usually one connection means one number of parameter. And in GPT-3, we have this 175 billions of the parameter, and the rumor says there's a 100 trillion parameters. It's significantly larger. So here comes to my personal guess. Of course, it will be more than 1 trillion because you can see from the previous scaling law picture here, we are kind of getting the next magnitude over years. So given that we are already there in hundreds of billions, 1 trillion is not a big issue, and it's a reasonable thing to expect. And I'm afraid it's not more than 100 trillion because given the current computational resources we have, given the current amount of data we have, I feel 100 trillion might be too large to train, unless OpenAI has something like magic, I don't know. So if you think about how can we deploy our own GPT model, how can we train our own GPT model, based on my lab's experience, we can at least afford something like fine-tuning a GPT-3 scale model with a cutting-edge NVIDIA A100 cards, and you definitely need more than 8 cards than this to do this. And that single machine can cost already hundreds of $1,000s by machine itself, and you need to consider the electricity and all the other things. But if you roll back to BERT, if you roll back to Elmo or GPT-2, you can afford it using a slightly weaker machine, but it's still a high-end GPU server. And if you think about all this, then it's definitely creating some barrier for the entry level for this AI game. But the good news is the OpenAI API is actually cheap enough. My student has been playing with those APIs for a while, and I told them to try to spend the money. I will support your research. And after a month, they give me the bill. It's only $40. So it's really not that expensive. And I strongly encourage you to give it a try, and you can understand what's going on there. So we will have more open-ended discussion, but I will just try to give a short discussion myself here. So there are many people saying that ChatGPT can be the spark of the AGI, the artificial general intelligence, and which I can see some hope to. And how can we deal with multimodal data? GPT-4 already did that. Then if there's a GPT-5, we also need to think about what kind of a data source we can use to train an even larger model. From the machine learning perspective, we always expect a larger model needs more training data. We already use the image data, then what's next? My guess will be video or maybe some other audio or data that widely available online. And also the impact to the education, whether or not we should include a ChatGPT in our curriculum, like whether we allow the student to use this for their homework. I think there are already a lot of discussion going on campus, and I'm happy to see the Academic Integrity Office will be involved in the later panel too. And with there are definitely impact to the domain size to our daily life and also the job market. There are many people, like master students, asking me like, how do you think about this job market things? So I have a feeling that if your work is closer to the machine, if your work is closer to the computer, it will be more likely your job will be affected. I'm not saying replaced, but affected by this ChatGPT stuff, because it's easier for them to get the training data from your job routines, and it can automate some of the modules in the middle and make your job easier. So my understanding for the AI is more like augmented intelligence. I would expect AI will augment the capability of the human. And if you think about what are the strengths of the AI, it's actually complementary to human. ChatGPT-3 used about 45 terabytes raw text data to do the training. How can we imagine we can read such a large number of documents? I mean, including all the people in the room, I think throughout all our life, we probably cannot read through all the documents there. But the good news is AI nowadays can help you to read this probably in a week or even less, and master most of the knowledge there. By saying master, it means the AI can complete 90% or even more of the sentences in the training data without any error. So you can imagine that it's kind of a new, much larger Wikipedia, and it tells you all this domain science, all these real questions. It can answer these things for you with arrows. And what we can do, human is actually good at judging the correctness of the question or of the answer. Then you can do your own research and you can verify whether it's correct or not. So to me, it's more like so my background is more in computer science by PhD training. So to me, it's more like another P and NP questions. In P questions, we can find efficient polynomial solution to fix this. And in NP problems, we can verify the answer using the polynomial time algorithm, but we cannot find an efficient enough algorithm to find a solution. But ChatGPT gives me some hope that it can propose some solution. Well, it can be wrong, but we can, as a human, we can quickly verify whether this is right or wrong. And we can criticize which part is wrong to ChatGPT, and it can give you a new proposal. And if you do this back and forth for a few rounds, you will be able to find some reasonably good solution. At least it helps me to find some piece of code that I want to write from the web too. And I try to use a Google to use a Microsoft Bing to search for it. Doesn't work very well. And then I turn to ChatGPT, only 3 rounds of conversation, it generates the answer that I'm looking for. And I can verify the correctness myself. So it's more like reducing the problem of finding a solution to just judge the correctness of the solution. So that's kind of the hope I see. And I think that can be a very strong use case in many different applications. To give a summary to what we covered today, it's ChatGPT is basically a GPT model that can chat. And the GPT is a large language model trained by reading the documents from the left to right to understand what's going on there. And I also put together a recommended reading list. I know it's long, but that's really the history, a short history of these large language models. So in the first one is attention all you need about transformer. And then you can see the Elmo, the bird, the Bart, the hugging face, all these things. And the language model are few shot learners. That's the first time people think about the in-context learning. And then we have this instruction following things. And there's another more comprehensive survey about pre-training prompt and prediction, this new paradigm and emergent ability I mentioned, and also the spark of the AGI. This work provided by Microsoft research people who have the best access to GPT-4 model. And I think they did a lot of things to do the benchmarking to understand what's going on with this extremely large language model. And there's another one about the benchmarking for ChatGPT. The conclusion is it's a jack of all trades, but master of none. So it can do a lot of things, but not the depth is not good enough compared with a well-trained domain scientist. And instruction tuning with GPT-4, there's very new work by the Microsoft people. Again, they try to use the GPT-4 to tune smaller large language models, and it can be something more automatic, like a recursive call to these large language models. But at the end, it's 2 blog posts by OpenAI about their products. So that's pretty much all I'd like to share today. Thank you.
Thanks, Jingbo. So we'll come back actually to talk about more of the technical details of ChatGPT later in today's event. Right now, we have Professor David Danks, who's a professor in HDSI and in philosophy, and also on the National AI Advisory Council, if I got that right, who's going to talk about the ethical implications, if you can search through all of my 3D printing files.
Yeah, that's right.
Cool.
Yeah, apologies that the slides were not on here. That is entirely my fault. So, but let me just fix something here. All right. So thanks so much. I think it's really great that we're having these discussions, that we're meeting as a collective to try and work through the kinds of issues that are raised by these technologies that actually do have capabilities that are really quite different from what we saw 3 or 4 years ago, even with AI systems. The sort of transformation that happened in a lot of ways in AI in the mid to late 90s was actually that as a community, we stopped trying very hard to build general intelligences. For the most part, we shifted much more to finding very narrow problems, optimizing the heck out of them. So all we want to do is find cats in our pictures. All we want to do is distinguish a wolf from a dog. All we want to do is plan a route through a room. And we're not going to worry if a system can do lots of different things. We don't care if our system is multi-purpose. It can beat a human in Go. That's all we care about. And who cares that, at the end of it, the human goes home and cooks dinner and the computer gets turned off, right? We didn't care because we were trying to build what we think of as narrow AI systems that were incredibly good, better than human performance at very specific tasks. And what we're really seeing, Jingbo made reference to artificial general intelligence and the claim coming, I'll do it as a claim, I'm not going to say that it is, but the claim coming out of the Microsoft group that GPT-4 is showing the sparks of it. I don't know what that means to say sparks of general intelligence, but the idea is that as we've seen these large language models and other generative AI systems emerge, they are much more multi-purpose. They're no longer the kind of narrow, we know exactly what they're going to do and we can optimize and control their performance in the ways that we're used to. They don't look as much like tools anymore. And this is raising a lot of ethical concerns, a lot of ethical questions. And so much of what I want to try to do here in the next few minutes is just raise some of these ethical issues and talk very briefly about some of the challenges that we're facing with these systems and the challenges with doing anything about them. Because I think it's tempting to look at these and say, well, let's just not have them do the bad stuff. And I want to talk a little bit, no equations, I promise, about why it's so hard to have these systems do the kinds of things we want and not do the things we don't want. So I want to start, though, with a sort of very high level, kind of quick discussion of something that may be coming to many of your minds, which is, okay, ethics, the ethical implications, that's just about what we do with the systems, right? You might be thinking to yourself, ChatGPT, there's 175 billion parameters. Those parameters are numbers. The whole thing, it's just math, it's just code. Ethics doesn't have anything to do with code, you might be thinking. You might be thinking to yourself, all that matters is how we use that code. But the first thing I want to say is, I want to push back on that and get you to recognize that in fact, technologies embody and implement values through the capabilities that they provide, through the affordances that they provide. You can think of this as when you have a hammer, everything looks like a nail. And so if I give you a hammer, you might say, well, there's nothing ethical about a hammer. It's only what I use the hammer to do. But in fact, there is a sense of value associated with a hammer. Namely, it says it's a good thing to pound on stuff. And so we can think about, in the case of ChatGPT, what are the values, the capabilities that are provided and the values that are advanced by those capabilities? Right? We can think about the kinds of user interfaces. What are the things, the safety, and I'll put it in scare quotes, that OpenAI has built as a layer on top of ChatGPT, where it will say, I'm sorry, I'm not going to answer those kinds of questions, except then you ask it to tell me a fictional story involving the thing that it says it won't answer, and it'll answer it for you, right? So it's very easy to get around their safety rules, precisely because the safety rules are essentially just looking to see, they're essentially just pattern matching on the prompt. Okay? And so the user interfaces, the conditions in which we deploy these systems, who gets access to these systems, these are also promoting some values, advancing some values, harming others. And perhaps most importantly, there's what we call the success criteria, the success conditions. For ChatGPT, success is it predicted the correct next word. Success is not it told me something true. Okay? It just does not care. There's nothing built into the system that says you should tell people true things. All that's built into the system is you should predict the most likely next word. Now, thankfully, the corpus of text and images that it's drawing from is mostly true stuff, because we humans, this may sound crazy, but we humans tend not to lie to each other. Okay? And so as a result, it's trained mostly on true things, but it will very confidently make things up. Justin gave us the example of the papers. A colleague of mine was sort of curious last December and said, the course that she was planning for winter quarter, she said, give me 20 readings that I can give to my students. And it very confidently gave 20 readings for this class. And the person looked and said, my God, these papers are amazing. I can't wait to read these. 0 of 20 existed. Every single one was made up. They were attributed to real people. So it got the authorship right. These are people who work in this field. Every one of the papers was made up in terms of the title, sort of like the acute feline laryngitis, which now I'm curious if it's actually a thing. So this is a persistent problem. It's not designed to succeed at giving us information or truth. It's designed to succeed at giving us the most probable completion. Right? And so that's advancing certain values, not others. And so when we think about ethics and technology in general, you should always be asking whose values are being advanced or harmed by which uses. It's not just about the code. The code's amazing, it's beautiful, but the ethical considerations require us to think about the people. Who is benefiting from this? In what ways? How might we shape the uses in order to ensure that we're, for example, advancing the benefits for the most people as opposed to for the very few, which raises lots of questions about how these things are being deployed and used. So I want to start the sort of deeper dive, though, on generative AI systems. And I'm going to use that as a general term. So ChatGPT is a kind of large language model, which is a kind of generative AI system. It is generating, in this case, text. But you can think about DALL-E or Stable Diffusion, which are image generation systems. You can think about much of the deepfake technology and software, which can be audio generator. With about, nowadays, it's down to about 5 to 10 seconds of audio. Somebody can produce a audio of you saying anything they want, and it is not distinguishable to the human ear that it is artificial. It's only about 5 to 10 seconds of audio of you. So if there's a YouTube video of you out on the web, somebody can create indistinguishable to a human audio of you saying anything they want. That should terrify you. These kinds of generative AI systems are now moving into the realm of video. Video has sort of been the last frontier that they've not been good at. They're now starting to get okay at 5 to 10 second clips. You might be thinking about deep fakes and saying, well, but those are video. Deep fakes take advantage of the fact that it's not entirely generated. They're just manipulating certain parts of the video. This is from scratch generated video that is close to indistinguishable to the human eye and ear. Okay? So everyone kind of expects that within 12 to 18 months, you'll be able to generate 5-minute clips of video that you can't tell a machine produced. Right? So you might be immediately thinking, this is terrible, to shut all these things down. I do think it's important to recognize that there are some benefits. There's no question that these technologies can enhance creativity and expression. One of the great uses that people are already putting the GPT and other large language model systems to is for proofreading and editing and summarizing. And they're pretty good at those kinds of tasks. If you are not a native English speaker and you want to write something that you think your English is not great, ChatGPT will automatically turn that into entirely grammatical English. If you aren't comfortable writing professional emails or professional letters, it will, you sort of write what you think, which is not very good, it will turn it into very good text. If you think about the image generation systems, they are already being used in very innovative ways by artists who can explore the possibility space for creative expression in ways that they aren't able to do when they have to generate it all by themselves. Because one part of creativity is coming up with a new idea. Another part of creativity is being able to recognize amazing ideas when you see them. And as Jingbo said, one way of thinking about this is these systems can generate a lot of things, and then the human judgment comes in, not in the creation, but in this discernment to say, this is exceptional, that's not. Right? So the ways in which people are partnering with these systems, I think, is leading to an increase and an advance in the kind of creativity and expression that people are able to put forward. Another really important value that is under-discussed and not, I think, is sort of coming very quickly on the research side, and at certain companies, there's a lot going on behind the wall along these veins, but is generating more useful simulated data. So Jingbo mentioned that you could use health records. UCSD Health has a large number of health records. I do some AI work on biomedical data. I do not want access to UCSD Health's records. I don't want that, because then I'm in trouble if something happens to those. I'd much rather have somebody say, here's a whole bunch of simulated data about fake people who don't exist, but it's completely realistic. I'd love that, because then if somebody steals my computer, I'm not stressing. I'm stressing out, but not because I lost control of a bunch of data. I don't have to satisfy HIPAA because these aren't real people. And we haven't been able to do that. Producing realistic simulated data has been a kind of holy grail for a lot of people in machine learning that we just haven't been able to get good enough simulations on. That's starting to change with the emergence of generative AI systems. And that has the possibility to enable real advances in healthcare, in finance, in many different sectors, in ways that are actually privacy preserving, precisely because people can do those advances without needing access to any real data. They can run it on simulated data and get good answers. So I think that this actually is potentially a massive benefit of these systems. We tend to think about the ways in which generative AI systems seem to be privacy invading, and I'll talk about that on the next slide, but they actually have the possibility of making it so that we can be even more protected in our private data. Because now we don't have to be sending data over email. We can send simulated data, not real data. I do think we should also recognize there is a benefit in certain tasks being able to be outsourced to technology. I really like that I have a spell checker on my computer. That's a good thing. That has made my life better. There were people who were sort of threatened by spell check and by grammar checking. That's going to end editors. There will never again be editors. Well, that isn't what's happened. Instead, it's just a lot easier to write because I don't have to waste cognitive energy on some of these things. I like having an automatic transmission car. I'll admit it, right? Some technology makes our life easier because there's some things that I just don't want to have to do. Now, the problem, of course, as we'll see on the next, we'll discuss on the next slide, is there are a lot of things that these systems are doing that is not just eliminating or reducing the amount of menial labor, but I think it's important to recognize the benefits of some tasks I'm perfectly fine outsourcing to a computer to help me. That one's a short slide. This one's the longer slide, which is thinking about the ethical challenges. So obviously the most obvious one, the one that leaps to enormous numbers of people's, to pretty much everyone's mind, is that these systems have the capability to massively increase the scale and magnitude of harms that are done to people, both on the intentional side, disinformation. I mean, we thought the scale of disinformation we saw in 2020 and 2016 was problematic in the elections here in the United States. None of us are prepared for what's coming in 24. It's going to be a disaster, I predict. And I'm sorry to be depressing on a lovely Wednesday morning, but it is an enormous challenge that we are facing. Even the unintentional ones. We have cases where things are being presented as hallucinations. It's cute and funny when it's hallucinating an academic paper that I can do a Google search and recognize, whoops, that doesn't exist. There was a newspaper report just a few days ago about one of the systems hallucinating a sexual assault report of a law professor. In fact, the article that I was drawing from was the law professor helping to support the victims of sexual assault. But the large language model hallucinated it as the professor was the perpetrator of sexual assault. And this is potentially being presented as truth, even by people who are they're trying to use these things just to give me a summary. But then all of a sudden the summary is giving a hallucination. And I think what this really raises is the enormous problem of these things being an ethical challenge of these being deployed on us as unwitting, unconsenting subjects. These systems are being deployed at a society level scale without any of us agreeing to them being deployed. We are the subjects of a massive experiment. And every time you use ChatGPT, every time you use Bard, the Google search that is connected to their back end, every time you're using these systems, they are collecting your data. They're collecting your prompts. They're collecting whether you liked the answers. They are adapting. Every case that somebody has come up with where they showed ChatGPT saying something silly, within about 2 hours after it gets publicized, ChatGPT no longer makes that error. And it's not because it's learning really fast. It's because part of what OpenAI is doing, and Google does it, and they all do the same thing, is when something gets noticed as this was dumb, they fix it on the back end, sometimes in an ad hoc way. We are the subject of a massive experiment happening right now. And I lived in Pittsburgh during the time that self-driving cars were being deployed and tested on the streets there without the consent of the citizens. And I saw how upset people were about that. The same sort of thing is happening now worldwide. We are being used as subjects in a massive experiment without our consent. And I think that's an enormous ethical challenge. Another problem is who owns all of this? Who owns the training data? All of those, every website that's out there and publicly available, that's now training data. Is that fair use? That would be the legal question. Is it ethical to be accessing all of this? Who owns the products? We're seeing this right now with artists and the image generation systems that are being built. Who owns the images that are being produced by these systems? It's also ownership of the technology itself. As most of us who work in this field have found, these systems are very closed. Jingbo referred to GPT-4, where we really have no clue what's going on with it. We don't know anything about it. We can't access it. OpenAI is no longer open. We might think, oh, okay, we'll just open source this. That's what some folks at Stanford did with what was called Alpaca. And then they immediately said, wait a second, maybe we shouldn't be open sourcing this incredibly powerful technology and just throwing it out in the world so anybody can use it. Maybe that was a mistake. So we have this tension between people wanting to get these systems out in the world so they can be improved, creating harms along the way, and then we don't know how to have recourse because nobody knows what's going on with a lot of these systems. We don't know technically which things were defensible errors and which were mistakes. There's the general problem, what we call de-skilling, where you lose skill because you stop doing things. So I'm happy to de-skill in terms of spell check. It's okay with me that I have technology helping me out with it. I'm not okay if airline pilots de-skill on their ability to land a plane. Right now, autopilots are better than almost all commercial airline pilots in almost all settings. And I don't mean that to denigrate or critique the skill of commercial aviation pilots. It is to say how good autopilots actually are. We do not allow planes to land on autopilot in this country, precisely because we want to make sure that aviation, that basically pilots maintain the skill of landing and takeoff. Because those are the two things that you have to be able to do as a pilot. If the technology fails, we've got to be able to get the plane down safely. And so we don't want to have de-skilling of pilots in terms of their ability to land a plane. So we have to think seriously about what are the skills we are going to lose by the widespread adoption of these. It won't just be for the menial tasks, it will be for creative tasks. There's at least one advertising company that has publicly said that they want to go from a team of 50 to a team of 5. And they want to do that because they think ad copy is going to be easy to generate. We'll just have somebody who can say if it's good or bad, and ChatGPT or some other large language model combined with an image generation will generate 5,000 ads. And so the job of those 5 people will simply be to say good, bad, good, bad. That's changing the skills that are required potentially in problematic ways. And I think it also calls into question sort of what we might think of as the nature of our humanity. We like to think of ourselves as special, that language is one of the things that distinguishes us from the non-human animals. Interesting questions there. One of the things these systems have shown us is that our language is a lot less special than we thought it was. We all like to think that we're geniuses coming up with brand new ideas every time. And what these systems have really taught, I think, many of us is our language is a lot more formulaic. It's a lot more ritualistic than we think. If I said, it's a beautiful day, I'm going to go sit outside. Pretty much everyone's got autocorrect. It's a rainy day, I'm going to go sit, right? That's formulaic. That's what these systems are doing. They're picking up on the fact that we are very predictable in our speech. And this, I think, is an interesting challenge to the way we think of ourselves as humans, to the special nature of us as humans. If language is a lot less special than we think, then that raises questions about, are we as special as we think? Obviously, dogs don't build universities. There are, the proof is in what we can do. On the other hand, it, I think, raises a lot of interesting ethical questions about how exactly we are different from, say, non-human animals. Now, it doesn't entirely do it. ChatGPT is really bad at causal reasoning, despite sorts of things that you sometimes see. And so I think it's important to recognize that there still are a lot of skills we have that these systems don't. But it really challenges, I think, our identity as special. So what can we do? I'll go quickly here because the short answer is there are no good answers here. And I'm sorry, again, to be depressing on a beautiful day. It is too late to have what we call dissemination restrictions. The horse is out of the barn, the genie's out of the bottle. These systems are not going away. We can't stop them from being out there. We can slow them, we can restrict in some ways, but we can't stop it. There was recently an open letter that said we should pause development for 6 months. I read that letter and I thought to myself, to be blunt, what's the magic that's going to happen in 6 months? That's not going to solve any of the challenges on the previous page. The idea was, let's wait for 6 months and we'll figure this out. We're not going to, because these are deep, intractable problems that we need to be wrestling with to try to understand what it is that we can do with these systems to have them benefit all, as opposed to benefiting just a few. And so a pause in development is not going to do it. We can't put the genie back in the bottle. These are multi-use systems. They are starting to be more general in their intelligence. And so putting prior restrictions on use is incredibly difficult. You know, as we said, you can say, oh, you know, don't say things like, to use one of the horrific examples that has been used, you know, you should not be a Holocaust denying AI system. And yet, if you ask it to write a play about a Holocaust denier, it will do that and say all the things that we think these systems ought not be advancing. So you can't really do prior regulation because of how multi-use the systems are. There will always be ways around the regulation. You might say, well, we can do social norms, whether on the development side or the use side. Maybe we all just agree that we're not going to do certain kinds of things. CRISPR is actually an interesting example of this, because when CRISPR emerged, what quickly developed was a social norm amongst the biotechnology community that we will not use these things on the human genome. We've known how to use CRISPR on the human genome since the very beginning. And yet there's only one documented case of somebody doing research applying CRISPR to the human genome. And that person was immediately, essentially excommunicated from the research community and ultimately ended up in jail. So social norms can be very powerful. The problem is that there are tremendous economic incentives to be a bad actor here. And so I think we can make some progress with social norms, but they're not going to fix or address the challenges on the previous stage. And you might say, well, let's just wait and see what goes wrong. And people are going to die. That's the scale of harm we're talking about. We can't just wait for the harms to happen and then fix them after the fact. That's also not an acceptable answer. So the best hope we have is to actually try to do all of these. So I think that that's what we're already starting to see. We're already starting to see companies pulling back on the technology that they put forward. You have companies like, for example, Anthropic coming out and saying, we are not going to make ours publicly available to just anybody because we think that's the wrong thing to do. Right? We're going to make it available only under certain conditions and only to selected users. We saw the Bing rollout happen very quickly. Google's Bard rollout is happening in a much slower fashion. So we're already seeing slowing in the dissemination. We're already seeing some pausing in development in the sense of things not being put out quite as quickly. There is real talk of how we can do some kinds of regulation or control. Some talk about the kinds of recourse that should be available. If a system says this person, you know, is guilty of sexual assault when they're not, who can they sue? What is the legal recourse that's available? And we're seeing, I think, the emergence of social norms within the community. It can be a little bit scary if you're sort of not in the community because you might wonder, do any of the people at these companies talk to one another? And I can tell you, they all talk to one another. And they all talk to people who are thinking about these things outside of their companies, whether in academia, government, the nonprofit, civil society space. All the conversations that are happening here, they are happening every single day amongst the people also building these systems about how do we do this better. And that's maybe the thing that gives me the most hope for the future, is I think that unlike some technologies where it's taken years for people to recognize the ethical challenges, I think we already see it after just a few months. Now, harms have been done, harms will continue to occur, but I am cautiously optimistic that as a community, both academic communities such as here, the broader community of people working on these technologies and generative AI systems, that we can make real progress moving forward so that we can minimize the harms and maximize the benefits. Because I do think these could be transformative, but only if we work collectively. So that's the hopefully optimistic ending. And with that, thank you. And we'll move to the next phase.
Thank you, David. That was incredibly interesting and very sobering, I think. So we have a panel next on the implications for healthcare, business, research, and art. So we'll set up for that. Okay. So it's my pleasure to introduce the panel on implications for healthcare business, research, and art. So we have Dr. Chris Longhurst joining us via Zoom. Dr. Longhurst is the Chief Medical Officer and Chief Digital Officer of UC San Diego Health. We have Tiffany Amariuta-Bartell, who is a professor in HDSI in the School of Medicine. Vincent Nijs, who is Robert Toomey, who is a professor at the Johnny Carson Center for Emerging Media Arts at University of Nebraska. And then Vincent Nijs, who is a professor and associate dean of academic program in the Rady School of Management. So I'd like to start with a question for you, Dr. Longhurst. So the latest public version of GPT, GPT-4, has famously done very well on professional exams, including the bar exam and the US medical licensing exam. And this has led to provocative headlines such as, can ChatGPT be a doctor? So my question is, can ChatGPT be a doctor?
Well, first of all, thanks for having me. And it's a little bit horrifying seeing the room to see how large my head is. It's really an exciting time. You know, I'm a cautious optimist, and we've been implementing electronic health records and other digital health tools for 20 years. And so we really have a preponderance of digitally available data about both patient care and how we deliver patient care that is exciting to think about how we can use with these tools. At the same time, this is a high-risk environment. You know, we're caring for patients and sometimes hold their very lives in our hands. And so we have to be very thoughtful and measured in terms of how we implement these things. And so as an example, just this week, we were announced as one of the first partners in the country with our electronic health record vendor, Epic, who is built, of course, on the Microsoft stack. And so we have operationalized GPT inside of our electronic health record for a very specific use case. And so I'll just share this slide for a second in case anybody wants to scan the QR code. But the use case is very specific, which is we've become overwhelmed with messages from patients, particularly since the pandemic. As we've delivered more and more virtual care, our patients contact us for asynchronous questions. And of course, our clinicians don't have time set in their schedules to respond for all these messages. And so the use case specifically is that we're going to, or we are using GPT now to help draft messages that our clinicians can then edit before they send. So that helps to address a couple of issues. You know, one is our previous speaker was talking about the errors GPT can make when it hallucinates. We don't want any hallucinations going directly to our patients. And so the editing, of course, is critical. The second is that our clinicians know their patients in ways that our systems won't always have the data that suggest. And so our clinicians will be able to edit the tone of those messages to make sure it's appropriate for those individual patients. And then finally, we always want to test things really thoroughly in a rigorous and disciplined way before we turn them on kind of writ large. And so we're working with a group of primary care physicians that are part of the pilot. We're measuring both quantitative and qualitative feedback to make sure that this is both improving patient care, response times, clinician satisfaction, and patient satisfaction. And so we'll learn more over the coming days. So again, I'm bullish and cautiously optimistic, but we have to be careful and measured in our implementations.
Fantastic, thanks. So I want to go to Vincent now. So we've seen how ChatGPT is an excellent chameleon of sorts in that you can say, write an email in the style of Shakespeare and it'll do that. So it can generate text tailored to a specific audience or purpose. So how do you foresee this changing marketing and advertisement?
Well, so David had a good example about the ad agency that was going to use ChatGPT to generate ad copy and then have the copy editors be literally editors. And I see that as a famous example already of Stitch Fix. So Stitch Fix is a customized fashion company, and they are doing something very similar, which is for their ad copy, they're having it being generated by AI, and then the copy editors editing. They do the same thing with product descriptions. So there are many thousands of product descriptions they have on their site, and they need to be carefully edited to be consistent with the brand message and the values of the company. And so they now have that generated by AI, again, edited by the editor. So there'll be significant implications for the number of people that they need to employ as copy editors. I think it's not just marketing, obviously. If you think about finance, if you think about business analytics and data scientists in companies, all of them have an opportunity to be much more effective and efficient, also have opportunities to expand beyond the skills that they usually were using and the technologies and tools that they were using. And ChatGPT makes that possible. There are definitely going to be implications. I don't think we're anywhere near yet where it could literally take over an entire person's job, but it can take over tasks, and it can enhance the ability for people to do tasks more efficiently, more quickly. So I think there's widespread concern about the implication for the job market. I think there's going to be a lot of reshuffling of positions and changing of scope of positions. Again, I don't think it will replace a specific person, but I like this quote from somebody I follow on Twitter who said, AI will not replace you, somebody using AI will. And I think that's incredibly likely.
Thanks. Yeah. So Robert, this next question is for you. We've mostly focused on GPT, which is a system for generating text, but there are other models such as DALL-E for generating images, and soon, as David said, video. So these models have rapidly grown in quality. And so I saw just this last weekend, the judges at the Sony World Photography Awards awarded a prize to an AI-generated image. They didn't know it was AI-generated. So this has raised concerns about the place of AI in the arts. Do you see generative AI and the creative arts as necessarily being at odds? Or is there a place for AI in art? And can AI-generated art be considered authentic in a sense?
Well, yeah, great questions, Justin. Yeah, so I think, so I'm speaking from the perspective of a practicing artist, working with emerging technologies, and also a researcher who's kind of building some of those technologies. I think the first part of that, sort of like, are AI and art at odds? First, I just want to say, I think these contemporary, like, large language model or deep learning based generative techniques are just kind of the last point in a long arc of technologies that artists have engaged with, or emerging technologies. Oil painting was at one point an emerging technology that allowed for like more persuasive representation of light, of flame, of transparency. Same with photography, in some sense was an emerging technology that replaced like painting, drawing, other kinds of traditional representation. So we see this again and again, and I'd say that the tools that are available now are in some ways just a continuation of kind of being the latest emerging technology that artists will readily and happily adopt. I think the more complicated question though is like, in what way are these tools different in kind from those other ones that I mentioned, like Photoshop, photography? To some extent, we're getting better tools, but traditional, like with Runway ML is a company in New York that is manufacturing kind of web-based video editing tools that do things like background subtraction, depth of field, at a level that would take a lot of human labor to do. So it's kind of that idea of automation, maybe of menial work or things that David mentioned earlier. So better tools are one thing that we're getting. Another thing I think really is like maybe new tools or new modes of interacting with tools. I think, we see, thinking about these language generation models and then also about these text to image models, those are kind of intervening at the level of like concept or ideation or language, which is a different place for a computational tool to be for, say, a visual artist or a filmmaker than some of these other kind of like, traditional technologies that are used in those practices. I think also we have, these things can play new roles in kind of giving visual form. I mean, maybe back to the menial labor part, text to image generation allows people who say can't draw or 3D render, produce images to represent concepts. This can then be used for like storyboarding, ideation, kind of like some phases of creative production across all kinds of fields. So I guess to come back to this idea of authenticity, I think that's a pretty loaded term in the arts, but one that artists love to think about. So, authenticity could be have to do with sort of, in what ways do these tools facilitate like an authentic expression or exploration or critique? Harkens back to like Walter Benjamin and the idea of the aura, the handmade that has some presence. So are the outputs of generative systems authentic? I think it depends on how you use them, right? It also raises this question of attribution though. So whose data were these tools trained on? Whose style are we using as keywords to prompt images? And also just like what biases exist or distributions, in the training data, because those things, limit the space of what can be expressed with these sorts of tools. And also raise all kinds of issues about, copyright kind of attribution, creative work. So I think I'll leave it there, but just that, I think, as a visual artist, I might criticize the outputs of some of these like text to image systems and things like DALL-E. Actually, I wanted to see who has used like DALL-E, Midjourney, Stable Diffusion. Okay, try them out. You can also find those online. But I'll say, as an artist, sometimes I might criticize these is wonder if they're a normative influence. Are we just kind of reproducing cliches, recognizable styles, trademark styles by artists? So I think, yeah, I don't know. That's an open question here. Sort of, do they expand the creative possibilities, or are they sort of reinforcing existing patterns, methods, tools?
Yeah, interesting. I think a quick follow-up. I mean, I've seen ChatGPT called a blur tool for the internet, or a blurry JPEG of the internet. Is it is DALL-E a blurry JPEG of art?
Yeah, and what art? I mean, there's so many different art worlds, right? Like a lot of images were scraped from like, I forget, like Deviant Art or something, like these kind of like online, bulletin board style posting things. So like that's one art world. There's like the art world of historic European paintings. There's so many art worlds, experimental videos. So it's blurry. Yeah, that Ted Chang article is ChatGPT, a blurry JPEG of the internet. There's so many kinds. I guess yeah, I don't know. There's so many, it's hard to imagine a totally inclusive system that could capture those nuances of like style and origin.
All right, thanks. So Tiffany, next question for you. We've seen that large language models are models for predicting at the simplest level the next word in a sentence. And so you work in genomics, and genomic data is in a sense text. Mm-hmm. It's a sequence of G's, C's, T's, and A's. So I'm curious if the underlying technology of large language models has been put to use in genomics for maybe predicting the next gene in a sequence.
Yeah, thanks, Justin. This is a great question. So actually, for quite a long time, these LLMs have been used in genomics, and there's a few examples, at least one of which I'll give today that a lot of you have probably heard of. But first, I just want to lay the groundwork for why applying large language models to genomics is actually much more complicated than applying it to human text. And so, for example, the sentences of human language, we have words, they are units and building blocks that we can work with. DNA sequence, on the other hand, is 3 billion base pairs with no spaces in between. And so at the level of regulatory elements and enhancers, us as scientists, we still don't have a good idea where these start and end. A lot of them are also context specific, and we don't really know all of their functions. Aside from that, there's all these higher order interactions between not only proximal spaces in the genome, but very distal connections. And so that makes it even a harder search space to deal with. But one example, and possibly based on this description that I just gave, making the jump from DNA sequence to amino acid combinations, which is much more similar to words in a sentence. So LLMs have been used for protein folding. So a lot of you have probably heard of OpenFold or DeepMind. And this is effectively a model where the input is an amino acid sequence and the prediction is a full 3D atomic resolution image of the protein. And this is incredibly useful because you need this for when you're working on drug discovery. You have to have a very high resolution image, a concept of exactly where every single atom in that structure is located in order to understand the binding dynamics, like what that drug might do, like in vivo, things like that. And often experimentally, when you try to generate this image, not from an AI-based model, you can get a blurry image. And so actually like these models that have been trained and applied, trained on millions and millions of sequences and have predicted many, many 3D protein folds have been highly accurate. And also, you know, they save all the laborious experimental effort that, so just pointing back to what David was mentioning, this is a perfect example of where you can automate something that gets near experimental accuracy and also has a lot of healthcare implications. Aside from that, more recently, there was a preprint on bioRxiv about predicting the next COVID-19 variant using large language models. And this is just a preprint, but still, so just keep that in mind. So it was based off of a collaboration between NVIDIA and researchers at UChicago and Argonne. And so it's really interesting because you can also use large language models for modeling evolutionary trajectories in genomics. And you can use that to predict where's the next mutation going to be, and it might not just be in the spike protein. And so this is really helpful information that can accelerate the development of vaccines, or also just like have it ready, you know, in our back pocket for when these new variants do arise. And sort of looking toward the future, I'm excited to see if large language models will be able to do this task that I think a lot of experimentalists would be really thankful for. So for example, if I asked ChatGPT, can you generate me a DNA sequence that has a specific functional effect? That would be excellent, because then you could you could have a very controlled experiment. You could, you know, design all of these sequences that you can transfect cells with and observe if you know, the functional effect that could be important for disease. And so I hope that that's where the future is going, and we can automate that process.
Yeah, I think what unfortunately comes to mind, I think David mentioned the scale of bad actions that large language models open up. And so we could imagine a large language model being used to develop new vaccines or a DNA sequence that has a particular function, but those might not be good functions, right? So do you see a danger there?
Absolutely, definitely see a danger there. There's just from I guess like a standpoint of also privacy, and I feel like there have been a lot of maybe high media coverage stories about, you know, generating either viral sequences or other sorts of sequences that, you know, could essentially qualify as biological warfare. No, and I not to sort of like put too much emphasis on it, or but yeah, there are examples out there, and so there's a lot of careful regulation that has to be accounted for, because you could literally order whatever sequence you want and then unleash sort of you know, a very damaging effect.
Dr. Longhurst, I'd like to go back to you for the next question. So on one hand, ChatGPT seems to offer upside. So it offers patients the ability to access medical advice, low-cost medical advice at all hours of the day, which I think you were referring to earlier. But at the same time, there are clear and obvious dangers, especially given that it tends to hallucinate and make things up, okay? But given the trade-off, what do you see as the role of ChatGPT in between the doctor and the patient?
Yeah, that's a great question. And we've seen a lot of examples of hallucination of GPT, even in healthcare settings, which is, you know, obviously concerning. So I mentioned previously that the way that we're dipping our toes in the water at UC San Diego Health System is by using GPT to draft responses to patients that will then be reviewed and edited by clinicians and members of the care team before that gets sent. There was an article just published actually by Dr. Peter Lee from Microsoft showing examples of incorrect output by GPT. For example, when asked, how'd you learn so much about metformin, a diabetes drug? GPT says, well, I received a master's degree in public health and volunteered in diabetes clinics. Interestingly, though, then GPT-4 can be used to validate itself, right? And it recognizes that, in fact, GPT should not be answering in that way. So this is something we've been thinking about even prior to the large language models. We've been working on a variety of different AI and machine learning algorithms in our healthcare system. And so imagine that if you spoke with your doctor, would you rather have them in a situation where they didn't have confidence, make something up, or say, I don't know, and I'll get back to you? Well, certainly we felt like the I don't know was the most appropriate approach. And so our team has actually taught a sepsis prediction algorithm how to say I don't know in about 8 to 10% of cases where it doesn't have enough information to make a confident prediction. And so we've been testing this in production now for 6 to 8 months. We're getting very positive results. And one of the things that we're hearing from our clinicians is the fact that the algorithm will say I don't know is actually increasing trust in the algorithm. And so, conversely, obviously, these large language models, hallucinating and just making up answers is decreasing trust as well.
Okay. Thanks. I want to go to Robert now for the next question. So GPT is very good at imitation, as we've seen. One of the striking applications of this that I've seen is you can, for instance, by giving a model and fine-tuning it, your text messages, maybe a text message conversation with someone, you can have it replicate that person and their way of speaking or yourself. I've actually seen people use this to build an AI chatbot that imitates a deceased loved one, for instance, which I think has mind-bending implications. But your work is kind of in this area, the intersection of empathy and human-computer interaction. I'm curious what it can tell us about sort of the good and bad of that sort of application.
Great, yeah. Yeah, noted chatbot conversant, Robert Toomey. Yeah. I mean, so I'd call this like all this realm of kind of imitation, intimacy, or desire for companionship, or even beyond that, maybe a desire for like communion, some kind of like deeper, like meaningful connection to an other, human or non-human. There's such a history in computing with this, right? Like back to the early days of programming, Joseph Weizenbaum at MIT with ELIZA, this therapist, really simple therapist robot, bot that he wrote, which got his employers and friends like hooked, basically, and this totally threw him for a loop. And you mentioned the Jessica simulation, or more recently, or also like Eugenia Kudia's Roman simulation, which replaced kind of a loved friend, which is now turned into this company, Replica.ai, which their business model is really kind of creating custom chatbots that you can have ongoing relationships with. So I'd say my question with this is always like, what are we interacting with when we interact with the model? That these things construct like affect loops, especially if you're talking about like deceased loved ones and things, there's a kind of like self-comforting or psychological self-stimulation that you're looking for from that interaction. I think also there's like an inherent theatricality to it that humans, kind of like anthropomorphization, humans want to read intent, want to project like a coherent subject onto the thing they're conversing with, but it's all this kind of theater. You've kind of loosely skinned something as a certain kind of character. And so it's really like a space for projection. So yeah, I guess like, thinking about risks and rewards, I think on the upsides or possible applications, loneliness is a thing and has real health consequences. So I think ideas of bots that could provide some kinds of companionship, can be a wonderful thing. Maybe also to some extent, maybe this problem of like hallucinations or truthfulness don't matter as much in some kinds of casual conversation or some kinds of interactions, although you wouldn't want like a companion bot to go off the rails. I definitely think these things can serve some psychological needs. And the question for me is, I think the clinician on the call, some others might have more informed opinions, but there's a company called Wobot making kind of a therapist bot, like, it can maybe serve some need, but can it have a clinical or therapeutic use? I think in the world of arts, like we welcome the hallucinations. Maybe it's just about the affect and kind of the interaction. Yeah, so maybe these things work best in kind of, more performative or arts sort of frame.
Interesting, thanks. So I want to open up the next questions to the committee or to the panel. Academia. So it's likely that the introduction of AI is going to change the nature of work in a lot of fields. So what skills do you foresee becoming less important because of these generative AI models, and which skills do you see becoming more important, perhaps?
So skills that are going to become more important, in some ways, maybe creativity and the ability to go outside of your usual box. I think of AI in some ways as, access to coding, where now you would go and do a hello world. Now you can do something like that, but on steroids. So anybody that isn't even familiar with coding or maybe wants to try a new language, they can get started and build real things very quickly, which also has lots of risks if they open up their computer hard drive to things, for example, or networks. But I think there's lots of opportunities to expand outside of the box where you usually are, just because this makes it easier for you to get a step. And it's also not judgmental, right? So if you make a mistake or you don't know something, you're not maybe as afraid to ask for something, whereas this will just tell you that information.
All right, so for skills that we can probably, lessen our attention on, aside from, the easy ones like spell check and code checking. I was really trying to give ChatGPT the benefit of the doubt when I was thinking about this one. And I realized that a lot of successful interdisciplinary science has been done by linking concepts such as, like, I'll give the example of like pre-2000s computer science algorithms. Just in the last 10 years became really popular in genomics. And so I was thinking across disciplines where, me as a geneticist is not necessarily exposed to concepts from other fields, this sort of AI could make inferences about what could be useful methodology across disciplines and could maybe accelerate our ability to apply other methods to new problems. And I was thinking that maybe instead of waiting for the time to pass to think of these natural connections, it could suggest them to us much quicker. And then in terms of skills that we still need to make sure that we are top notch on, critical thinking and interpretation are super important, because I've, just like David was mentioning earlier, I've had the same problems with ChatGPT about making up sources, making up citations, papers that don't exist, trying to cite authors who I had as previous coworkers, and I knew that they hadn't researched those topics yet. They, ChatGPT said this is the conclusion from their paper, and I said nope, they've never researched that. And so just like making sure that we know how to use ChatGPT as a tool rather than like a truth. And so using it as a search, much like one learned how to use Wikipedia, one learned how to use Google, and let that be sort of the tip of the iceberg in your search on whatever question you're asking, and following up with like actual sources and making sure that they're correct.
Thanks. Yeah. We're running a little bit over, unfortunately, but I want to thank all of the panelists for being here. We'll take a quick 10-minute break and then we'll resume with our panel on technical limitations. Thanks.
Hold it right here, you'll be good to go, okay? From now on, thank you very much. And then, front or behind? Yeah, best switch your phone off.
I can see their faces.
As long as it's in the light and plus behind. Yeah, okay, fine. Here's what we're gonna do.
All right. Hello, everyone. Welcome back to the panel on technical limitations of ChatGPT. So I want to thank our panelists, Mikhail Belkin, professor in HDSI, Zhiting Hu, also professor in HDSI, Dheeraj Makala, PhD student in HDSI, and Zihan Wang, PhD student in HDSI. So I want to start with a question about your experiences with ChatGPT, where you've seen it succeed and where you've seen it fail. So while ChatGPT has surprised many with its abilities to do complex tasks, such as solve that puzzle I showed early on today, it can also fail at relatively simpler tasks, like counting the number of words in a sentence. So can you characterize the task that ChatGPT maybe doesn't excel at? What does it struggle with? And why does it struggle on problems like that?
In my experience, the ChatGPT specifically struggles with problems involving multi-step reasoning and any mathematical reasoning and logic. So, for example, if it has to use its previous answers to answer the next question. For example, if there is a query, how many World Cups did Italy win between 1960 to 70 when Pele played and India was ruled by Great Britain? So there are like so many complex queries in that, and it has to answer each one of them and aggregate. Sometimes it gets it right and sometimes it does wrong. And as you have said, like, the counting, anything that involves reasoning and, computational logic, some mathematical reasoning stuff, it gets wrong. That's what I observed in my experience. And I mean, to answer the next question, like, why does it get wrong? Because it was trained on, next word prediction task. So the first thing, the next word prediction task doesn't necessarily, explicitly ask it to learn the logical part of it. And also the second thing is, once it gets a single token wrong, there is no way of fixing it back. So, there is like an exponential, the probabilities of getting it wrong gets exponential high as it generates longer sequences.
Thanks.
Also what I observed is that ChatGPT sometimes like it cannot like faithfully answer like what it actually knows and what it actually doesn't know. So for example, if I just ask him like who Zihan Wang is, and it will try to make something that looks logically correct. Maybe it saw my personal website online. It will scratch some of them, but say that I'm a postdoc at CMU, which is absolutely incorrect. I never searched as Zihan Wang at CMU. So it tries to make something correct. So it has this ability of generating like fluent sequences that somehow matches like certain like keywords, but it doesn't really know like what are the correct like factual knowledge that exists in the world. So that's kind of one of its limitation, I think. And the reason that it isn't able to answer that, I feel like it's partially because of it's never trained on such data before. It never has the enough exposure to data such that it needs to faithfully answer that. I never saw this before. I have to say, I don't know. Probably it was trained on a bit of it, but it's not enough to match like all the abundant knowledge that it hasn't exposed before.
Right. So I kind of want to follow up on that, the problem of hallucinations, because I think maybe the first thing you might think of is, well, why can't it just cite its sources? What are the technical limitations that would prevent a large language model from saying, this is where I found this information?
Yeah, I think the research for citing its source is currently happening, and there are even some, for example, UChat, I think it cites its sources. Yeah, so this is like exploring. This is the research that is being explored now to cite its sources. But yeah, as Zihan said, the space of possibilities and impossibilities, the space of impossibilities is comparatively much larger than the space of possibilities, and it is not being exposed to the space of impossibilities to say that it is not possible or it doesn't know about that. And citation might fix it, and it's the research is going on towards that.
So anybody else? So earlier, Jingbo talked about how large language models are growing in size in terms of number of parameters, also in terms of the size of the data set that they're being trained on. And so I want to ask the current deficiencies of LLMs where we see them struggle. Do you have a sense that it's just a matter of increasing the amount of data, increasing the number of parameters, or increasing the number of GPUs? What are sort of the bottlenecks to improving the performance of the models? What do you see as the trajectory there?
Yeah, okay. So I think, scaling, right, in terms of data and the model size, will definitely kind of further improve the performance of ChatGPT, right? We saw, like, say, GPT-4 is kind of better than GPT 3.5 on a lot of problems, and maybe GPT-5 is even stronger. But I don't think, scaling is everything. As the other panelists, they mentioned those problems, right? ChatGPT cannot work well at this point. For some of the problems, I don't think scaling can solve them. So one particular example is, those problems that requires, explicit tracking or maintenance of the word state. Like, say you tell ChatGPT, you have an apple in the fridge, and then you took that apple and put it on the table, and then you continue to tell ChatGPT that you did a bunch of other things, like, say, whatever, you replied an email, you drove to the campus, whatever, and then you ask ChatGPT, where's the apple? ChatGPT cannot answer that because it basically does not track the status of the state of the world. It's just a kind of language model that's simulating the next words. So that's kind of a fundamental limitation of the formulation, I think.
Yeah, I also feel that scaling, well, on one hand side, we consistently have seen that scaling the number of parameters and the number of the amount of data has led to improvement in performance. So no doubt that more data and more parameters will help. I'm also, I think there is a limit, like even when we go to effectively infinite number of parameters, there is a limit to how much performance you can squeeze out of that. On the other hand, I would like to say that what we have seen, if you told me 5 years ago that these models would do what they're doing now, I wouldn't have believed it. So I think our predictions should be maybe taken with a little bit of a grain of salt. We didn't see this coming, so I'm not like super confident that, yeah.
Yeah. So I guess to summarize, would you consider any of the limitations right now to be fundamental to the model itself, the technology, transformer architecture? Or is this just going to be, it's just a matter of more data?
I would say the formulation or next word prediction it has the fundamental limitations, basically. There are a lot of things you need to model, basically, beyond the language and beyond this next word prediction. So that's my take.
Yeah, I sort of, my rational mind sort of agrees with that, but honestly, I don't know.
I have a small point to add. I mean, for the next word prediction, our intuition behind that is like, as you scale up the model and as you increase the data, the model sort of understands the context in a better way to predict the next token. But yeah, as Professor Zitting said, it doesn't remember the state very well. If, even if you increase the model or, even if it increases the data. So there is some fundamental limitation that I believe for the next one, next token prediction task.
I can add another different perspective. I think it's a slightly different. So I feel like if ultimately we just want a machine that can answer all the questions, then it's possible that we can just regardless of human effort, just gather all the possible questions in the world and just annotate them all with a wrong truth answer and feed it to the model to train it. But the crucial point here that I view is that the data is just too much. We cannot afford to really gather all the possible questions. We cannot afford to actually annotate all the possible questions. And we have to rely on the model to generate some of the questions to answer the other questions. And that point is what I feel like could vary very differently, between some tasks that is easy to generalize and some tasks that will be hard to generalize. And the logical tasks that was just discussed before, I personally view it as some tasks that is quite hard to generalize because first, it doesn't really naturally exist in online data, and second, it doesn't really it's kind of like the learning to the function that maps the input to output could be very hard for the model to understand because it involves like complex logic. So for me, like the architecture wise or the I'm not sure if transformer is the best, but I feel like it's more on the training procedure side. How do we actually allow the model to train in a way such that it learns how to generalize better? That is another limitation that I feel like could be the bottleneck.
Right, thanks. So speaking of training these models, they're trained on large amounts of text data on the internet, and it's speculated that large amounts of the internet will become generated by AI in the next few years. So the question is, does this pose a problem for the training of the model, given that it's trained on its own output?
I personally won't be concerned much about training the language model in the future using AI generated data because there are techniques being developed to identify the AI generated data. So I guess we can always filter very accurately to identify the human generated data out of and the whole internet and just train based on that. But I mean, I think the more difficult problem to solve is it's not very evident for a human to say this is AI generated or human generated, whereas algorithms can do that, but for human it's difficult. So I think the disinformation will be a bigger problem than training data for language models.
Yeah, I do have a worry. People are using ChatGPT to help them, write text or produce whatever they want to write. So we do have a project trying to study this problem. We call it pollution by those large language models, to the web. So, it's not just about like say all the training data on the web, are created by language model and how that would impact the next say GPT-5. We may also worry about how the use of ChatGPT may impact the human language, right? Like say ChatGPT may have some pattern or bias on using some of the words instead of other words. Would this gradually reshape how we human use language, right? And would that eventually lead to the change or shift of even our human culture, right? So that's kind of the problem we're kind of thinking about. Of course, it's kind of a very high level abstract problems when not sure yet.
Right, so I want to talk a little bit about the sense in which these models develop a world model. That I realize this is very speculative, but in the intro today, I gave a problem where I said there were two rooms and each room has a window on the north side. And Alice is in the first room and Bob is in the second room. And they couldn't hear, they had earplugs in. And there's nothing in either of the rooms, but Alice has a cell phone. She's going to get a message and she has to relay the information that she got a message to Bob. And the model said that what she should do is shine the flashlight of the cell phone out the window onto the ground so that Bob could see the light and infer that she received a text message, which seems to suggest that the model understands a lot about the world, right? And so I guess the question is, these models are trained just to predict the next word, right? Do you think that's enough for these models to build a rich understanding of the world like we have? Can it emerge from that sort of training process?
Well, I think it's very tempting to say that we have a unique ability to build world models, but it's hard to see why it cannot have a world model given that what we observe about its behavior. I mean, if you think about the human intelligence, it's a product of, like few billion years of evolution, right? Which allowed us to build the models that we have. Certainly for each individual human, we learn from much, much less data than those models have. But it's sort of, I don't see any fundamental reason why a world model cannot be obtained from this sort of collective output of, human thought that it's being trained on. I think an issue with that, of course, is that the models, at least as they are now, they don't have access to the physical world. They only have access to the social construct that the humankind produced. But as far as the model is concerned, I would say that probably we can argue it has some sort of world model.
Yeah, I agree. Like, I do think large language models are a type of world model because they are modeling language, and the language itself is a representation of the world, right? We use language to describe the state, the action, right, and then how the state will change. So, as for simple next word prediction model is a world model, right? So, but the problem is that language is ambiguous, and the language is very noisy. So that kind of determines that the large language models are noisy and kind of ambiguous. Also, language is not the most, many times, it's not the most efficient representation of some of the world states. Like say we have two chairs here. You want and my question is, what are the differences between these two chairs? Right. So you can use language to describe the difference, but it's very difficult. You have to say a lot of things. There are a lot of nuance differences here, right? So sometimes it's easier to just post the two images, right, of the two chairs, right? So images are more efficient representation for this particular question, right? So large language models using language to represent the world or to kind of model the world is very powerful because language is powerful, not because the next word prediction is powerful. But it's not complete, and it's not efficient enough in many cases.
Thanks. So I want to catch up on time, but I guess last question, any bold predictions for the next 5 or so years? I won't put you on the spot, but I just did. Yeah, I think this is motivated by Minsky saying in 1970 that in the next 8 years we'll have human-level AI, and I think if he were alive today, he might make the same claim again.
I won't make any bold, but Sebastian Bubek from Microsoft, who is actually a theoretician, leads a theory group at Microsoft Research. He has been giving talk. They just published a 100+ page paper on various aspects of GPT-4. They got to play with it earlier than other people. And he's been going around giving this talk titled First Contact.
So I suppose it should be stated that Microsoft, which Bubek works for, is a large funder of ChatGPT, OpenAI. Yeah. All right, so I want to thank the panel for their participation today. And so it's my pleasure to introduce Stuart Geiger, who will be talking about the implications for disinformation and social media.
All right. All right. Hi, everyone. So I actually had a close personal friend of mine record a little bit of an intro for me. So hold on, let me get this all set up.
Hello, San Diego. This is President Joe Biden here. Sorry I couldn't make it to Chatting GPT. It sounds like a fantastic and very important event. But it's my honor and privilege to introduce our next speaker, who asked me to say a few words. Now, in my time in public service, I've gotten to know some exceptional, brilliant minds. But when it comes to the impacts of artificial intelligence on truth and knowledge, there's really only one person I turn to. And that's Professor Stuart Tiger, who teaches both in communication and data science here. Not only is he the most brilliant person who I've ever met, he is also my very best friend in the entire world. Please don't tell Barack that. I met Stuart back in 2010 when he was studying misinformation in Wikipedia for his PhD. Anybody could edit Wikipedia, so I kept changing. Hello, San Diego. This is President Joe Biden here. Sorry I couldn't make it to Chatting GPT. Derailed and hurt people? Me off with a warning. Very best friend in the entire world. But please don't tell Barack that. I met Stuart back in 2010 when he was studying misinformation in Wikipedia for his PhD. Anybody could edit Wikipedia, so I kept changing the photo of Mitch McConnell to a turtle. Within 2 minutes, he caught me, but let me off with a warning. Stuart has dedicated his life to unraveling the mysteries of AI and how it impacts our lives. He's a lot like that scrappy kid from Scranton, fighting for the little guy, cutting through the malarkey, although I never had hair like that majestic mane. Straight talk, folks. Technology is moving faster than a high-speed train, but are we sure it won't get derailed and hurt people? And where are the tracks going anyway? That's no joke. We're more divided than ever, and we know people will use AI to pull us farther apart. Sure, we've always had misinformation, which back in my day, we just called it malarkey, or propaganda, doctored photos, quotes out of context, and some people feel no shame to straight line to your face. But something seems different. You know, every week it seems there is a new AI released that can bring benefits for sure, but also can act in dangerous ways and bring real disruptions to people's lives. There's a hot news AI startup that makes a voice changer app. It's like ChatGPT, but for audio. They make money letting anyone impersonate politicians and celebrities. They say they only need a 15-minute recording of anyone's voice to build a model that lets you speak in real time as if you were them. They encourage users to upload recordings of other people's voices, and there's a whole gallery to choose. Their most popular model, the one that they put the most time into that works the best, and the one that you don't have to pay for, it's my voice. They stole it from me. They say it's only for parody and entertainment, but we all know what's going to happen with this technology in this political climate.
You're wrong, Joe. This is brilliant, because now if I get recorded saying anything, I can just say fake AI. It's the new fake news. I love it.
Hold on, I thought we banned Donald from the Discord. W did that.
Yes, we banned Donald from the Discord server, but that's not him speaking. Look at the icon. It's your buddy Barack.
Oh, I got you there, Joe. Isn't it crazy what these AI technologies can do these days?
Hold on, give me a minute. I'm just trying to record an intro for a talk that Stu's going to give at this Chatting GPT event at UC San Diego.
Stu Geiger? I love that guy. He always has really smart things to say about AI.
Well, yeah, that's exactly what I'm saying. We're trying to say.
Is he going to talk about fake audio and video? Like, did you see that TikTok that was of you, me, Trump, and Drake, and we were all at the McDonald's arguing about what to order? That was hilarious.
You know I'm not on TikTok, Barack, but yes, I saw it on Reddit.
But did you know that I made it? With a little help from Sasha and Malia, but it's really easy to do now. I didn't have to do any coding. I just download this app, choose my politician, and spoke into it.
But this isn't just fun and games anymore, Barack. You're not in office anymore. I am. If there's fake audio that makes people think that the president of the United States is saying something, that have real political consequences.
Well, look, back when I was president, they didn't need AI to push the conspiracy theory that I was some kind of secret radical Muslim born in Kenya, did they?
No, but just imagine if they did.
There will always be people who think the only way to win is to lie and manipulate the truth, no matter what technology is out there or how easy it is to make and spread fake news. Look, what is crucial are institutions that we trust to anchor us to the truth, to report on the world accurately and reliably, to filter out all the BX.
Do you just want to take over and give Stewart's talk for him?
Well, after all those late nights the three of us spend playing Minecraft together and talking about the future and the ethics and politics and sociology of artificial intelligence, I probably could give his talk for him.
Really? Let me just finish up this intro and then we can go to Area 51 and take a joyride on the UFOs, okay?
All right. Sorry about that, Stu.
Here we go again. We are living in a brave new world. I don't know what to trust anymore, and I bet you don't either. But you know who I do trust? Professor Stuart Geiger. So give it up to the eminent scholar who's making sure we don't get lost in the digital sauce. Stu, what do we do?
So that took me about 4 hours. And that included the first time I ever used this particular app. And I'm not going to tell you what it is because I don't want to give them free publicity. But it was the first time I ever used it. And a lot of that time was also coming up with the script. You can see here on their gallery, right, famous politicians, celebrities. And again, you can upload, and again, requiring no programming experience, no coding, just the ability to take a 15-minute audio clip and turn it into this for anyone else on the internet to use. And this is going to build on some of the things that Professor David Danks was talking about earlier. This should terrify you, right? But I also want to sort of note something that I did, which was that I did something that pains me, which I put a disclaimer there. And I thought that that was a responsibility that I ought to do, right? I'm a big fan of parody. I'm a big fan of satire, of irony. I think that plays a really important role in society and has for millennia. Which, by the way, if you haven't seen the Supreme Court brief that was filed by The Onion in support of a recent case around parody, you should read it because it's a masterwork of the genre that makes the argument that parody performs a very important social function by tricking people into thinking that it is real. That I wanted to have something where if I played that to you without giving the disclaimer, you would have had to exercise your critical thinking skills. You might have actually believed, oh, maybe this guy does know Joe Biden. I don't know. But then slowly, as I pivoted in the style of parody and satire from the serious to the funny and back and forth, making it more and more ridiculous, you exercise your critical thinking faculties. And therefore, you have the unique ability to critique and comment on this. But I chose to undermine, again, I really believe in humor. I feel it's important. I wanted to, make you all laugh, but I chose to kind of pierce and that wasn't as important as putting a disclaimer up, given, the context of where I am. We're at a university. We've got UCTV here. We're presenting to a very large audience. I am speaking directly in my capacity as a professor at a research institution. And so the thing that I was absolutely terrified of, and I think the thing that I decided to do to be responsible, to be a responsible user of this technology, was to put a disclaimer. Because this is the last thing that I want, right? And this is also fake. I'm pretty good at making fake stuff. But I also didn't want something like this to happen. Or if it did, I wanted there to be able to be some sort of original record where you could go back, the fact checkers could go back and say, no, this actually was part of this long presentation. Here's the official canonical video. In the same way that we've been debunking misinformation since the beginning of recorded history through institutions. Right? And I wanted to have Barack Obama say that about institutions because I want to believe that we live in a world in which our institutions of truth can protect us from this, that they are flexible, that we had things like this, right, that you might have seen go. And, it was one of these things that went viral, actually published before the arrest actually happened, which was a key piece of evidence that was used by all the fact checkers, right? To say, you might have seen this photo circulating around. They didn't use any algorithmic techniques. They didn't have this wasn't a technical solution to this technical problem. It was a social solution to a social problem that we sort of relied on our existing institutions to sort of triage and to say, we had a lot of news organizations there. All of them showed him in different clothing. And these kind of things have been core to journalistic institutions and other institutions whose role in society it is to anchor us to the truth and to filter out all the BS. But we've been doing this for quite a long time. This is the first famous war photo, right? Back in the days when photos took many, many minutes, sometimes hours to produce. You couldn't catch action shots. And it turns out this photo was staged a little bit. There's evidence that actually this is the first photo that he probably took where there was no cannonballs on the road. And the photo that ended up getting published, oh, there's a whole bunch of cannonballs. And there's a lot of evidence in the record that suggests that this photograph, this famous first war photograph ever taken and spread across Europe during the Crimean War, was staged in a certain way. So we've been having to sort of figure out these things as a society for a long time, right? We've also had propaganda for a long time. We've had nation state level actors and large multinational corporations that have resources who have been able to, develop and spread whatever sort of messages they want. We still do it today in analog form, even dropping pamphlets off of, to sort of spread a particular message with a particular impact. But one of the things that's happening today and with these automated generated technologies is that the scale is increasing and the cost of labor is going significantly down. It used to be the case that you had to be a security services of a nation state or a large multinational corporation to be able to have the human labor power necessary to carry out what are called influence operations. But one of the things that we're seeing is that, and you used to be able to, catch people who tried to do it with fewer resources, or they tried to do it kind of sloppily, not very well at scale, right? For example, this is something that kind of made the rounds during some of the Amazon unionization fights, where this is clearly kind of a fake account. It's got no history. You can do a reverse image search and find it's a stock photo of a guy who just happens to be a happy Amazon employee who doesn't want to shell out hundreds a month for lawyers. This was caught pretty easily because they probably didn't put as much work into it. But now we're going to have histories, entire accounts that have histories that seem real going back years. And the tasks and the techniques that we were used to be able to identify fake accounts or things like that, we're going to have to adapt. We're going to have to get better at that. Our institutions are going to have to get better. We're all going to have to get better. But the problem is our institutions aren't in great shape right now. I wish we had a thriving, functioning set of institutions that are enough of them to keep each other accountable, enough of them that are well-resourced to be able to go not just where the news headlines are, but where the next headline might be. But currently, all our from education to science to journalism, right, we are in moments of crisis around this. Right, we are going to be spending a lot more time being suspicious of each other, and that also takes a lot of labor. Right, we can't just put a magnifying glass up. We're going to need new technologies around detection. And some of that is going to have to come from these developers themselves. One of the things that I want to note, though, is that this takes a substantial amount of work. And I want to shift from, this isn't a misinformation story, but there's a famous case of a sci-fi magazine that had to cut off submissions because they kept getting flooded with AI-generated stories. And the editor kind of said, you can see this is the graph of number of submissions per month, and it kind of peaks at December and keeps rising. And the editor said something that I empathize with, and he said he wanted to believe and wanted to live in a world where he could just say, well, if it's AI generated or not, it shouldn't matter. If it's good fiction, we'll publish it. If it's bad fiction, we won't. I want to live in that world where we could apply that, but that's not the world that we live in. This publisher didn't have the labor to be able to do that. It takes time, it takes effort, it takes money, it takes dedication, it takes specialized roles. And so we're seeing this sort of being overwhelmed time and time again, sector by sector. I'll introduce you to Brandolini's law, which is also known as the bullshit asymmetry principle, right? Not a law, but a kind of an idea that the effort in debunking misinformation is much greater than the effort to create it in the first place. The amount of energy needed to refute BS is an order of magnitude or 10 times more than what is needed to produce it. Again, not an exact figure, but it's harder to debunk than it is to spread misinformation. In fact, there's an interesting study that was done where someone actually, so for example, lots of parts of the federal government are required to have a public notice and comment period before making major changes to policy. It's in the law. If they don't do this, then it's a violation of the Administrative Procedures Act. So they have to receive comments from the public. And one researcher basically used generative AI to create a whole bunch of content, actually submitted it to the FCC's notice and comment website. And then, it did not get detected. And then he took it down right before the end of the notice and comment period. But no one detected it. And he actually had a range of different people, look at this text, and they weren't able to detect it as well. But the thing is, he wasn't using ChatGPT, GPT 3.5, GPT-3. He was actually using GPT-2. And it was also the case for GPT-0, I guess, or -1, which is just having this Mad Lib style thing where you're kind of just randomly generating a template sentence over and over and over again. Humans can't detect this either, especially when we're talking about paragraph level comments or the size of social media posts. But one of the things is this has also been this idea is also kind of aligning and intersecting a bit with classical political organizing techniques. In one sense, this is actually savvy political organizing, right? There's guides on how to create an email template to help your social media followers flood politicians with messages about the protest. This is one from Amnesty International, right? That's sort of around the no ban, no wall movement at the beginning of the Trump administration that has, right, these sample Facebook posts to copy and paste and maybe modify a little bit, where it's sort of acting also as sort of an artificial organism. And this has been a constant debate, again, pre-AI, but on what is considered legitimate versus illegitimate forms of political organizing. Is this astroturfing, or is this savvy organizing skills in the digital age? So one of the things that I think is also going to be happening is these sort of second order effects of given independent of whether or not things are actually happening on social media. And we actually don't have a lot of evidence to know right now, like, is the GPT apocalypse, misinformation apocalypse upon us now? Or, how much is it actually happening? We don't really have good methods to detect that. But even the fear of this, I think, is leading to certain initiatives. For example, there's a lot more talk around requiring sort of real name policies or sort of ID requirements to be able to post on social media. And I don't quite know how I feel about that, because I think that can sort of lead down to some pretty dangerous roads as well, requiring to have a government issued ID to post on the internet. And so I wanted to kind of end by talking a little bit about the responsibilities of developers in this. And so this is the AI voice kind of tool that I shared earlier. They actually have an ethics page on their website. And so I clicked it, as one does. And they first said, yes, we want to help focus on the positive uses of voice technology. Every technologist thinks their technology is ethical because it does what they designed it to do. And we don't ever, we always think the things we want to do are good things, or else we wouldn't be doing them. Right. And so they said, we want to help people maybe who have disabilities or are trans and maybe want to sort of try out a different voice. They had a couple of these sort of positive use cases. But they said, we want to help prevent the misuse of voice technology. We provide an API to detect fake speech and prevent misuse, which I think, if they did that, that would actually be, some good due diligence to be able to say, well, maybe if we keep a record of everything that's generated and have some sort of ledger that the fact checkers can go back to, that can plug into our existing institutions that anchor us to truth, and provide sort of resources and documentation so that we can sort of know, this is a variation slightly blurred to get around the auto detectors, but we found something that this was actually generated in this case before. And so I contacted them on their public forum, and I said, this is great. Where can I find this? And they said, well, sorry, the feature is currently being finalized. It's not available at the moment. So their ethics page contains, am I allowed to say it, a lie? So I think this is also, so to conclude, I think we should be thinking about these in terms of a common problem in society that we've thought about how to tackle before in different sectors, which is externalities. Right? The idea that there is sort of private benefit, right? These companies are making money, they're getting massive amounts of attention, they are causing harms for the entire rest of society, right? Think about how many labor hours of work, those of you who are in education have had to put into your own curriculum and thinking about curriculum design and GPTs. That is a cost that the public is bearing for private gains in innovation. Same with pollution, right? You have a private gain to the factory, a harm to the rest of society. And so I think that we should be thinking about these kinds of things that are actually quite similar to other kinds of public policy and technology problems we've been dealing with for a very long time. And so I want to conclude by saying also that this is something that plugs into existing institutions and existing markets, right? There's a market for disinformation. There is demand for disinformation, right, from society. And the fact that we have increased supply and it's a lot easier to generate it, right? is independent also of the fact that there's demand for it as well, that there's big money to be made. And so, for example, if the Federal Trade Commission has authority, standing from Congress to be able to regulate unfair or deceptive trade practices, then I think it might be worth considering if sort of certain kinds of use, disingenuous use of this or non-labeled use in a commercial context or in a context of a political campaign might constitute unfair practices, which we already have laws against regulating. And so this might, not stop every single person, but if you want to be a part of this, if you want to, use this kind of technology, as part of existing institutions, existing organizations, existing companies, right? We have very strong things like whistleblower protections to be able to do this. And I think that, there's a lot of things to be done in talking about technological solutions, but I don't want us to also forget that we have social and political institutions that have been trying to deal with problems like this for a long time, not just fake news, but from tax fraud to insider trading to sort of violations of internal government policies. It only took one person to bring down the entire NSA kind of spying regulations when Edward Snowden leaked that. There's all kinds of these different sort of ways. And so I think that we need to be thinking about these things together and thinking about, especially the role that technologists play in their responsibilities to society. Thank you very much.
All right, thank you, Stuart. So we'll set up for our last panel of the day, which is the implications for education panel. All right. Can you see us? Leo, I think, Leo, can you see us?
Yeah, thank you so much.
Cool, yeah. Leo can see us. All right, so I want to thank you both for being here. We have Tricia Bertram-Gallant, who is the director of the Academic Integrity Office here at UCSD. We have Shannon Ellis, a teaching professor in cognitive science, and Leo Porter, a professor in computer science. Unfortunately, Leo couldn't be here today. He's got a bit of a cough, but hopefully you're able to participate. So I want to start with a question for Tricia. So I think when one first considers ChatGPT's implications for education, the first thing that comes to mind is students using the tool to do assignments, perhaps outside of the bounds of the syllabus. So you're actually holding a symposium this week on partly AI's impact on education and academic integrity. So I guess, could you give us a sense of in what sense there's a problem? Is the problem already here? And how is it different fundamentally from previous enablers of misconduct?
Yeah, it's here. It's inside the room. Yeah, tomorrow actually morning or at 11 a.m. is our student panel, and they're going to be talking about how what they think of ChatGPT, well, generative AI and learning and academic integrity. So I encourage you, if you haven't yet checked it out, to check it out on our website, academicintegrity.ucsd.edu, and you could still sign up for that one. So yes and no, it doesn't change things, right? 2008, when my first book was published, I said in that book, we need to stop asking, how do we stop students from cheating, and start asking, how do we ensure students are learning? That's picked up speed a little bit, but it's more relevant now than ever before, right? If we ask the question, how do we stop students from cheating? We're always in this cat and mouse game, this technological arms race. The detector conversation about should we be using detectors to detect when students cheat. Now, I think detectors have a real role to play, and we're thinking about disinformation campaigns and could help us save ourselves. But is that the right approach in academics? And really, so the causes of cheating are the same. Right? It's kind of a perfect storm of low self-efficacy, extrinsic motivation, which means I'm focused on getting the grade or the degree, and a performance orientation of the class happening inside an environment, whether it's a peer culture, institutional culture, or class culture. So that those things haven't changed. What I think Gen AI does is changes the opportunity, benefit, and cost. So the cost of engaging in cheating goes down because you're less likely to get detected. And the benefit goes up because it's faster, cheaper, and easier than, say, asking somebody else to write your papers for you. It's much easier to ask ChatGPT to write your papers for you. So it's the same. The temptations are still there. The reasons why students might turn to it. I think the question we want to ask ourselves, going forward in terms of thinking about, the answer is pedagogy, assessment, and culture, and it always has been. But I think what we need to ask now in terms of very specific to Gen AI is kind of what we had to go through with the calculator and other tools is, where is the boundary between cognitive offloading and cheating? We all cognitively offload all the time. And so we have changed the boundaries of when it's cheating, when we think cognitive offloading is cheating or not. And that depends on the assignment, depends on the assessment and the learning objectives for the course. So that's an interesting question I think every instructor has to ask themselves is, when is the use cognitive offloading and okay, because it doesn't undermine learning or assessment, and when is it cheating?
Fantastic, thanks. I want to flip it to Leo and Shannon now. So have you tested ChatGPT on your own assignments? I know I have. How well does it work?
Leo, do you want to go first?
Sure, either way. Yeah, so I have tested ChatGPT. I've been using Copilot, which is the LLM for programmers from GitHub. And let me just quickly say how well it does for introductory programming, and I'll talk about my later courses and advanced content. For introductory programming assignments and exams, it performs quite well. For exams, there's actually a study in my field of computing education research that looked at how well these tools perform on summative exam questions and found that Codex, which is a precursor to Copilot, outperformed 80% of introductory programming students. For programming assignments, the ones that the students take home and do, it does exceptionally well when students are asked to solve really well-defined problems, and just like you pointed out earlier. Unfortunately, that's how we design our programming assignments in our classes at UCSD and at other institutions dealing with large enrollments, because there are hundreds of students in our classes. Faculty tend to use tools to automatically grade student submissions. But in order to automatically grade student submissions, faculty have to carefully specify the desired behavior of the code. That carefully specified code behavior is exactly when tools like Copilot do really well. And so I think for introductory programming, it means we're going to have to change how we assess students. Just fundamentally is going to change. For upper division content, as of right now, who knows with ChatGPT 4 or 5, but as of right now, it doesn't do very well on advanced course content, like where I ask it to optimize code to perform better on specific hardware using the hardware specifications. Their ChatGPT does quite poorly. In fact, it gave me code that barely worked at all. And so there are certainly limitations in its abilities, but right now it's essentially as good as a novice programmer.
Ditto.
Cool, that gives us a lot of time to answer the next questions. Actually, I want to pick up on that because one of the things I've noticed is in how you assess, you might think like, okay, let's assess deeper, let's ask for explanations. And actually that I found that to be the wrong way to go, because ChatGPT, as Stuart showed, is very good at BSing. And when you're giving partial credit, that earns a lot of partial credit. So I actually have tended to ask a lot more very direct, very well-defined questions. And I actually started doing this in the pandemic when we were teaching remotely. And on my exams, ChatGPT gets like 40, 50% on like a battery of 30 questions that the answer is a number or something like this. It's actually impressively good, but it is a bit of an antidote, I guess. I think that leads us into our next question though. So Shannon, maybe you can tell us, have you found ways, because I think a lot of people are interested, found ways maybe of making assignments which are robust to ChatGPT? How has it affected your assignment building?
Okay, so I said ditto, not because I don't like to talk. I really like to talk. That's why I have this job. It was mainly because I wanted to get to talk to this topic, and I agreed with everything Leo said. So hopefully I won't blabber on too long here. And I kind of want to use the same breakdown that Leo did on this like lower div and upper div. And this gets back to what Trisha was saying about the course objectives and modeling things to make sure you're attaining them. And the objectives in an intro course are inherently different than those in an upper division course. And so to answer the actual question about how I've modified assignments or how I approach thinking about that, I'm going to first talk about upper division courses. I taught one last quarter, and on the first day I had this really great student, and he was great all quarter, and raised his hand. He's like, I'm talking about academic integrity. He raised his hand. He's like, can we use ChatGPT? And I was like, yes, you can. Next question. And then it was like, wait. And they're getting this different from each professor, and they should ask about it. And I said, well, I'm going to be running my stuff through ChatGPT. You can too. And I'm going to be designing it in this course so that you can't get everything right. And you need to think critically when you run it through there, which things it did get right and which it didn't. And when you do that, you're getting to the course objectives of this course, because it was upper div, it was using data, analyzing data. And if they asked ChatGPT, I did it for all of mine. It was going to get some things right and not others. And they had to think about what was and was not right. And so in my mind, in that course, go wild, do whatever you want. And that one. And so that same student throughout the quarter, they have independent, like he came to me and he's like, so I've pulled back on when I use ChatGPT. I don't want to use it like immediately because I'm not learning as much. And he's self-regulating. Not every student is doing this. But he came to them where, after the first midterm, he raised his hand. He's like, so you said you use ChatGPT, but I found that when I use ChatGPT on your exam, it got me the right answer on that one you said it didn't. I was like, okay, tell me your process. And he said, well, I put the question and it didn't give me the answer. So then I tried part of it. I edited the code and then I asked it a different question following up on that, and it gave me the answer. I was like, excellent, right? Like, I'm fine that it helped you get to that answer. I was like, if you put in just the question, it did not get you to the thing and you needed to figure out what you needed to do. So I felt in that class that just by checking and thinking about what ChatGPT was good with and what it wasn't, we would get to the course objectives. Now, the other side of that is intro programming. I'm teaching intro programming this quarter for the first time since these large language module LLMs have become pervasive as popular. I ran a handful of previous exams through and it aced them. Yeah. So my goals are that students learn the fundamental building blocks of programming and are able to implement them in the future. If I were just to set them free and use ChatGPT through the entire course, you could get through the course without learning, and you could do very, very well. So there, I changed my assessments. I changed my assessments when we went remote for Zoom, or went to Zoom, made them take home. That went really well. Students liked them, said they learned even more than, so that was great. They won't work now. And so now I did go back to an in-person conceptual exam. I'm not going to have students writing code on a piece of paper. They're never going to be doing that in their life. But they're going to answer conceptual questions, and then there'll be a take-home portion where they implement that technically, right? And so they have to do the concepts in class. They have to understand these building blocks. That's the time that they get to, and I tell them, show off what they've learned, right? Like, that's how I want them to think about my midterms. But I have had to change my approach to make sure that the assessments were matching the objectives. That was my long answer to make up for my ditto.
Leo?
I think that was a fantastic answer. I may do the same thing Shang just did, offer ditto, but let me just add maybe one piece to it, which is I think a new direction for these assessments is having computer-aided test centers, sorry, computer-based test centers, where students can come and they can take a test in a proctored environment. And Trisha really has led the charge at UCSD to have these kinds of test centers. Thank you, Trisha. You've already made all of our instructors' lives easier. Thank you. But I think if we could expand that operation, what you could do is then have these controlled environments where the instructor can specify when the student has access to these tools and when they don't, and they can move through the test in a really nice way. And so I'm really optimistic about that trend.
Okay, now I'm going to follow up on that real quick. So pre-pandemic, we did in-person midterms in my intro programming course that has like 350 students. And then we would have grading parties that would take hours and hours and hours, because I will not give a multiple choice exam in an intro programming course, because that doesn't accomplish the course objectives. Multiple choice exams are great for certain things. And a handful of TAs have been like, why don't we just have them do this on a computer? And I was like, because we just can't. We can't right now. And that is even more important now. So yeah, I'm grateful for the testing center now and where it's going. So I also ditto Leo there.
So I want to follow up a little bit about the teaching of programming. And I guess, one question is, do we still need to teach intro programming, given that GPT can do it quite well? But I guess one of the interesting parallels I've seen, or interesting ideas, is that, maybe 20 or 30 years ago, we learned very low-level programming languages. And nowadays we teach higher level programming languages like Python. And in some sense, Python is automating all of that messy work for us. And is this the new programming skill that we need to be teaching, is talking to an LLM and it just handles the low level details for us? Yeah, Leo, absolutely.
I can't really agree with you more on that sentiment. Computer science as a field, right? We've just every few decades we've advanced how we communicate with computers. I teach assembly programming for computer science majors because I think it's an essential skill that they need to know. But most people don't program in assembly anymore, right? Or programming in Python or in easier languages. And so I feel like this is just one more step to reducing the barrier to entry into the field of programming. But I would want to separate a bit students who are coming to be professional software engineers and what they need to learn versus all of the other people who need to learn how to write software. And that's such a huge group, right? That's scientists, social scientists, artists, musicians, data scientists, engineers, all these different groups, right, who need to learn programming. I'm not sure they need to spend a ton of time in a course focused on syntax, which is what a lot of introductory programming courses are about. Instead, I think they should be focused on new content and working with LLMs. And so this past quarter, I was on sabbatical, and I was working with Dan Zangaro, who's also within the field of computer education research. And the two of us really tackled how should we redesign an introductory programming class for students who just need to be able to write software, and maybe they're not going to go be professional software engineers in the long run. And as we did that, we also read literature, and we saw great articles like the one that Brett Becker put out last month, talking about how LLMs can teach students how to program by letting them see lots of different correct answers and then compare and contrast the different right answers. But I'm of the mind, and so is Dan, that things are going to change more fundamentally than that. I think the skills that students need to write software change when they use an LLM. And the old way of teaching introductory programming, focused on syntax, is just not important anymore with Copilot. On the other hand, some skills that are really important to software engineers, like problem decomposition, testing, code reading, that have always been on the kind of back burner because of syntax in those intro courses, now become front and center. And I know I'm talking a little while, just one more piece here, and that's in trying to design a curriculum for students to learn how to write software using LLM, we realized that the shift is so significant that us kind of just sketching out a curriculum and writing a paper about it was not going to be sufficient to make change. And so this is a bit of blatant self-promotion, but we decided to actually write a book on how to learn how to write programs using LLMs. And that's actually going to be coming out next month from Manning Publishing. And our goal really is to increase the population that can write software by lowering the barrier to doing so.
That's very cool. So I want to shift the focus to, I think the second thing that comes to mind when we talk about LLMs in education is this notion of de-skilling that David brought up earlier today, which is that, your mental faculties atrophy if you don't use them. And so if we have LLMs doing the intro programming, solving some of the easier problems, I kind of liken it to a surgeon, maybe who has been given a robot who can do the suturing, and so for the experienced surgeon, it's no big deal. It simplifies their life. But for the new surgeon, they've lost something. They've lost the practice. Mm-hmm. So how concerned are you about de-skilling? And what do you think the solution is? Should we withhold LLMs until people have reached a certain level of their education?
I think some people could make that argument, and I don't think they'd be wrong if they were to withhold, right? And say David's argument earlier, right, that we don't let them auto land and take off, right? Even though we could, and that when something could go wrong, you really want people to have the skill to make sure. And so you could take that same approach here. I would take the other one is let's make sure our students know how to use the tools that they have at their aid correctly, think critically from them. So yes, ChatGPT could take away all critical thinking, but you could also utilize it in the other way. So like Jingbo mentioned earlier today, using it to write exam questions. Lots of people have been doing that, giving you other thoughts. Anybody in my intro programming course on their midterm in 2 weeks, I haven't written it yet, but I know that I'm going to go to ChatGPT, ask it the same question a handful of times, get a handful of different answers because that's possible, and then have them think critically about the answers that come from it. This is not an original idea. Other people have tweeted about this. Lots of people are doing this. And so in my mind, withholding it limits the reality that students are going to be living in, but teaching students how to use it and to think critically on top of it, and then get to do, ideally, as we go further, do cooler things earlier, right? If we can teach the core skills faster and still get a true understanding where we kind of get rid of the need to teach syntax as hard as we do right now, as much as we do right now, I think we can augment critical thinking, but we have to do it thoughtfully. We can't just like expect it's going to happen. And I'm going to read that book.
So I wanted to, I guess, there's been a lot of concern or a lot of questions about the implications of LLMs for different careers. And I think teaching is one of the big ones. So, the absolute gold standard in education is one-on-one tutoring. And large language models, some say, will enable that in the next few years. We'll have AI teachers and tutors. So I guess the first couple parts to this question, are you optimistic or skeptical about that possibility? And then what becomes of the teacher? What becomes of the university in a world where LLMs are fantastic one-on-one teachers? And Shannon, I know you have to leave at 1, maybe.
Go ahead first. And then, yeah, thank you.
Well, you might as well just retire now. You're all out of a job. No. So, but I know some faculty that are saying that, like, I'm just going to retire now, and that's okay. So I'm extremely excited about this. So, and it's already here. Khan Academy is already doing it. Seneca College in Ontario, Canada is already working on, I'm sure other ones are too, but I saw their announcement that they're working on a individualized tutor system, which is fantastic because with the massification of higher education, with our 300, 400, 500,000 people classes, our students aren't getting a lot of individualized instruction. And we need to somehow enable that while still providing the fundamental and fabulous educational environment that we have here. So this is going to be a really great way for large research-driven institutions like ours to really become teaching institutions as well, in the true sense of a school where you have 25 or 30 people in your classroom. And what that will free faculty up to do, not only the tutoring thing, but the automation of writing my exam questions, grading my exams, delivering my exams in a computer-based testing center or learning center, we might call it. It will free faculty up, even if you have 300 students in your class, to actually get to know your students, to actually do active learning flipped classrooms where your students are coming into the classroom to engage with you, engage with each other in human to human relationships, because that's the thing that Gen AI can't yet do. I don't know how far in the future that's going to change, where we have these models of companions, but for now, it can't do that. And so I actually think that'll free faculty up from the drudgery of some of the work behind teaching and research, and free you up to actually be coaches, mentors, facilitators, assessors in a different way. Oral assessments, I think, they're already back in our engineering faculty, have been trying this out for a year now. That kind of interaction, and isn't that a good thing? Because we need our students to be able to communicate orally about what they know and what they can do, not just in writing. We'll be able to do mastery-based assessments where, as Leo said, they'll come to a testing center and they'll test once and be like, I didn't do so good, I'm going to try again. They'll get another individualized assessment. So I'm super excited about that, if you can't tell. It was a few years ago I said, why students cheat is we don't have 24/7 learning support for them. So they go to the platforms that are open 24/7. Most of them go to those with the intent to learn for help. It might end up in cheating, but that's not usually the intent at the beginning. So this is absolutely a game changer to have 24/7 legitimate tutoring support.
Shannon, did you?
Sure. So I might be slightly less optimistic than Trisha there. So I hope that Trisha's right on that. I guess I'm, when you teach really large classes, you're like always thinking about the things that are going to fall through the cracks or like where things are going to go wrong. And as this rolls out, there's going to be the growing pains as we figure out that. So I love the a model. And I think kind of we're in this transition period, particularly in programming courses where the model is going to completely change and it's going to get better. But we're going to have some hiccups along the way. So I love that vision. And I think that fits into the overall, what is the role of the university, and the role is to give students a dedicated time to learn more. And this will just be a tool to support that. So I think it supports that mission. I think the university's role is also to expose students to things they didn't know existed. And it gives them the time to explore those things. And I think that's my role as an educator. And I tell students in a lot of my classes, by the end of this class, you'll either know you like this more or you like this less, and either one is great. And that is part of education. If you get an A+ in my class and hated it, go do something else. And the university is a place that allows that. So I think my role as an educator will change. I would love to have more personalized education time one-on-one with students. And so I aspire to that vision. I just think we're going to have some bumps before we get there all the way, which Trisha didn't say we weren't. Yeah.
Oh, it's
Yeah.
it's just easy now. Yeah.
Fantastic. Leo, did you want to add?
Oh, I could just add two quick things. One reason I'm slightly skeptical about intelligent tutoring systems finally coming out is that LMs lie, right? And you can't have your tutor lie to you. I think that's going to be a really big problem. And until they get more accurate, I'd be very wary of having students get their tutoring help from an LLM right now. Another question, maybe I could turn this back to Trisha really quick, is we find with our students right now in introductory programming classes, they don't spend a lot of time, it seems, trying to solve it on their own. Once they run into their first road bump, they immediately go to our tutoring support for help, and then get unstuck, and then they just repeat that cycle. And I worry a bit about having a tutor immediately available the moment you get stuck. And I'm kind of curious how you might want to design a system, Trisha, that would avoid that issue.
Yeah, well, couldn't we, so I think this is why Seneca College is designing their own tutor rather than waiting for a third party to come out, right? So, and I don't know that, I'm just guessing. But so we could train the tutors to say, how long have you been thinking about this so far? What all have you tried so far, right? That's what a tutor does. Just so we could train the AI tutors to be the same as a human tutor. So your human tutor doesn't automatically start solving, showing the student how to solve. It's like, well, what have you done so far? What do you know? What do you don't know? What are your questions? You know what? You have only been thinking about this for 10 minutes. You need to go back and think about this for another hour and then come talk to me. So I think it's possible to program in those structures, those parameters around when the tutor can help and what the next step in helping is, which is why I think we can't leave it up to OpenAI and all of these other companies in doing it. It has to be paired with people who know about teaching, which is why I think the Khan Academy one's probably going to be pretty good and pretty powerful, but we'll see.
Very interesting, very insightful. And I think with that, that wraps up the panel and wraps up today's event. I want to remind everybody that this will all be recorded and posted on uctv.tv in the coming weeks. And I want to thank all of the panelists, all the speakers for today for a fantastic event. Thank all of you for attending, and go enjoy the weather. Take care.
Thank you, Justin, for organizing.